learning and create business value using the infrastructure of AWS as well. So second layer is going to be our focus as well, is basically platform is given to you. So does it require to be expert into the machine learning before they start their journey onto the machine learning on AWS? And in the morning, in the early morning, I also mentioned like our mission is to put machine learning in hands of everyday developer. So for that, we have machine learning as a platform available. So SageMaker is the answer to that. So it's a platform to build your model, train your model, tune obviously, and then deploy your model using the Dockers. We will dive into that as well. But just to mention, like if in case you are new to AWS, this can be your playground to try things out in the machine learning space. You are just one click away from each cycle of machine learning that I have shown you in the previous slides, the whole pipeline of getting the data to the machine learning point. That is pretty much, you can do half of the part using the SageMaker. And then the topmost is the AI services. You take the services, this deep learning services off the shelf, yeah, and integrate it with your solutions, or maybe use it as a standalone if you want it. So for vision, speech, language, chatbot, for enriching your applications, you can use as a API driven machine learning or deep learning available services for you. So for everyone, we have everything. So like in case you want to do it yourself, machine learning yourself, and that's a, you need a platform because you might be just starting up, and then you need not to write a millions of codes for your recognition, the images or the video recognition. You can just use these services off the shelf and you are good to go. Yeah. So our focus would be today on to the machine learning platform. We will see these in the demo as well. But having said that, we will also talk about the infrastructure layer as well. So here on we have I started mentioning like in the morning we had more than 200 new services and features launched in the space of AI and machine learning. You can see some of them in the onto the infrastructure side. We launched new algorithms, new frameworks available on our infrastructure side. If you remember, infrastructure is not shown here, like inference chips we launched, and this is new ML services we launched in the SageMaker. We are going to cover that, by the way, in coming slides. We have now SageMaker Studio IDE. For example, if like you have a Visual Studio to build, debug, monitor the whole coding, everything, right? You have done. For the machine learning, this is going to be your IDE, your studio, wherein you can work from the to tuning, deploying, and then further monitoring and debugging. And then there are others like SageMaker notebooks, and yeah, we have done a lot of new innovation, which we will cover in coming slides. And on to the AI side, we have for your search engine. So basically, Amazon Kendra is like can be a Google within your organization. Yeah. So for your searching internal organization, you can use Kendra. Fraud detector, like one of use case we are going to use today. For your credit card frauds, anything, you can use this fraud detection machine learning enabled service. And Code Guru is a very interesting one. We have a whole video for that, which I will share with you. Just to give you a synopsis, Code Guru is going to help you to find the expensive statements within your code. It is right now in preview, I believe. Yeah. So if in case not, you can try it out. Even in the preview you can try it out. So it can help you to find the expensive statements within your code and help you to mitigate and improve those code. Yeah. And currently supported by the Java. I think a few other languages are on the way. Very interesting one. Yeah. Okay, so there was a question around which persona you should be to cover which part. So here, let's see some of the persona for the TAM is basically for the relationship, understanding what the business problem is from your company. If you are having a salesperson or relationship managers who are going to understand from kind of customer point of view which problems they have, they typically comes onto the business problem framing ML problem part. Yeah, then data scientist, you would find them on most of the parts, right? From the data collection point of view, helping you to understand which would be uh, essential data preparation, and as such as on developers and DevOps would be coming typically onto the deployment part and the monitoring debugging part. Yeah. So here you can consider which persona you are in, and you can consider uh, where you would be adding the more value. Yeah. Okay, so how you can help your customers now that you know more about machine learning process, Amazon machine learning stack, and the three layer from infrastructure platform to the service. Here are the some tips on how you can add value to each machine learning project you take on. So you would find a different customers. It's very important you vet machine learning customers correctly, especially early in the project. So there are typically three types. First, who are just starting with it. Yeah, so they don't know much about the machine learning. Yeah. On to the other hand, there are specific customers who have the specific use case, but they do not have enough staff to support it. That's where you partner with your own information knowledge comes into the picture and help them to guide the whole path. Yeah. So what they lack in basically with their data science resources. And then finally, there are experts who are experts, practitioners who know the machine learning in and out. Yeah. So they are maybe they are willing to get the access to the infrastructure level so they can do the things themselves. Yeah, so you can help them aware about the availability of resources onto the AWS side from the infrastructure point of view, right? In a flexible way, and pay as you go things for you to use onto the AWS, so you can guide them in that regard. So yeah, most business problems are not ML problems. So if you remember, we mentioned AWS solution architect indicated like 8 out of 10 business problem cannot be addressed by the machine learning. There could be big data or any other problem which can be answered with. Yeah, so AWS leadership also states that many customers are just starting the machine learning journeys, and they have not thought about what they are going to do with it. So that's where partners going to guide them. So once what exactly you need to do is ask your customer if they are attempting to predict a number known as a linear regression can be helpful for them. Classify data as a one type or another, which is the classification, or group the random data point in some way, which is called clustering. So you can help them to understand the machine learning process altogether from the point they have a business problem. You can help them guide with which type of machine learning would be helpful for them, like supervised, unsupervised, or which type of algorithm can be helpful for them to get the answers. So that's wherein you can come in and help your customers making a decisions, right? So you can provide guidance to your customer through each phase of the machine learning process, from the business problem point of view to data collection, visualization, to the point of deployment. Okay, so that's where you can help your customers. Now moving on. So here we have now workbook on your screen. By the way, what exactly this is, to bring into the context, I will just take you uh, back to what we discussed. We are going to follow a case study, and this is the data we have from uh, this is the data available for all of the insurance fraud, or basically insurance claims being made already. Yeah, so you can find here the lot of columns, lot of rows. By the way, we have just taken a sample of 5 rows, and there are around 39 columns available. So column representing each features. So as you know, all machine learning problems start with the data. So this is a snippet of the data for any company, which is showing the car insurance claims being made over the period of years. So here their goal is to predict whether a new insurance claim is going to be fraudulent based on the history claim data or not. So they need a better process to determine this. So what do you think? Can this data and their business problem be formulated as a machine learning problem? Yes or no? What do you think? We have a lot of data here. I think we used as an answer before, like yes, we could use it because they were had a challenge of losing a lot of money, and also a lot of overhead, administration overhead was caused it because of a lot of insurance fraud claimed were made. Yeah. So what do you think? With this type of data, uh, which type of machine learning could address this problem? Supervised learning. Which type of supervised learning? Yes, you're right. Supervised. Sure. By the way, classification. Yes. So because the data is provided here with the correct labels and outputs, it's a good example of supervised learning. So here you can see the output, by the way, label, which is telling us if the fraud was made. Uh, it's talking about the output of it. So if it was a fraudulent, yes. If it was not a fraudulent, so that's a lot talking about the data. Yeah. So yes, we can use it, and I think 90 and 100% people have answered it correctly. We are going to use the classification for that. Good job, guys. So what do you think? Having a look onto this late data, I'm letting this slide be in there on there for a couple of more seconds. So what do you consider? Which feature for the machine learning problem we can use the most? Features we are going to talk about. There are two things: features and labels, right? So so which column would be considered features for the machine learning problem? By the way, except this column, we can use all of them as a feature, like monthly customer, age, policy number, policy date. But further on, we'll clean the data a little bit. Like you can see the police report variable might require, might not. We'll see further. Since there is some garbage in there as well, there is no data available, we have to clean it up, right? We'll see that further. Yeah. So yeah, so we will clean it further so we can use it. Please state as well, you are right. So good, good going on. So yeah, so good answers, everyone. So if in case I ask you lastly, which features would be most relevant to identify fraudulent claims? What do you think? Month month as customer, age, policy annual premium, policy report available, month as a customer, age. So yeah, currently we expect all state policy CSL umbrella limit So because you can see umbrella limit is a way beyond sometimes zero and high values. Yeah, so that might not be relevant. What else? Policy report available. Police, yeah, policy report available is one of them. Good answers. Injury claim. I think injury claim is required. Good answers, everyone. So we will use most of them except the state policy, CSL, umbrella limit, and policy report available. So without that, we will move on further. Okay, in our coming section, we are going to do a demo wherein we will be cleaning the data as well. So good answer, everyone. Yes, most of you won't be able to see the answers. That's why I'm speaking that out loud. What are the answers from everyone? So few of them we also reply to all, so you can have a look onto that. Okay, so now with that, we coming to the next part of our session, wherein we are going to talk about the data collection part, integration part, and preparation, visualization, and analysis of the data. So this is the part where we talk about the data, which is the king of everything with the machine learning. Yeah. So objective is that we be understood about uh, with the why data is critical to the machine learning problems. By the way, it's been already we talk a lot about data, why it is important. Yeah, so explain structured and what unstructured data is, what makes the most value out of data. It is structured or unstructured. Explain the purpose of data phases in the ML process. So there are different phases. We are going to cover that and identify the AWS services that used during the data collection, integration, preparation, visualization, and explain the purpose of SageMaker ground truth. So we will jump on to now somewhere at some point what ground truth is. So we will start with the SageMaker. So first, what are the data challenges in the ML projects we face? So all ML projects starts with the data. Data is the prime. So that would be the king of everything we are doing the machine learning, because it has to understood the pattern. It has to make a model that will be essential all about the right value data we have with us, right? So each project must have a clear business problem at first and objective in mind, and the data supporting the both of these must be gathered, cleaned, and visualized before it can be modeled to make prediction. Yeah. So ML require cleanest data. More than 50% of the project time is spent in gathering, cleansing, and visualizing the data. So there is a report you can find this 50% and 36% data. 36% see data dirty as the number one challenge is being uh, indicated by the studies done by Data Science Survey of 2017. So most of the part spent on cleaning the data. So major part, finding the most value of the data, those features, understanding the attributes, and then cleaning them off, like having not uneven values, lost values, formatting them in a right way. So we have a constructed, because everything here is in a computational. So in a machine learning, everything will revolve around computations, algorithms. So we need to convert the categoricals data as well, categorical data as well. So we need to cleanse it first. So understanding what structured and unstructured data is. Yeah. So when customer begin their data collection phase of any ML project, they must understand the type and structure of the data they are working with. If it is structured, coming from a CRM, coming from a ERP solution, would be a structured data. If a customer entering any forms are available there, that's a very structured data, very cleanest form of data available. like relational databases, you get the data from them. And then there is unstructured data. Any type of document, could be typically audio, videos, PDFs, documents, Word file, doc files, emails, calls, anything can be an unstructured data. Yeah. So with structured data, customer must normalize the data, meaning, for example, our record must have common fields. All fields must be populated with the data of same type, and data must not be missing. As we have seen our previous slide where we were seeing the data, one of the column was missing the data in it. Yeah. So we have to cleanse that as well. So yeah, data transformation and augmentation using the extract, transform, and load (ETL) job, basically. So there would be a lot of tools necessary for that. AWS does provide a lot of tools for ETL, processing it, and then storing infinite data as well. Yeah. So let's have a look onto that in the preparation phase. In the integration phase. First of all, what you need to do is bring the data, collect the data. So during this phase of the machine learning, customer collect data in a single format, maybe JSON, maybe CSV, tabular form. So data comes from many sources, including user activity, financial, third-party databases, or public data sets. So all of these sources must be integrated in some way. After collecting, integrating some way. Some of the services, if I call it out, S3 we use for housing the data. Yeah, so S3 is our more scalable, durable, highly available data service. Data saving, we call it storage for the internet. So you can put any amount of data, no restriction. Yeah, and then you can use Athena, which can also run a query directly onto the S3 to understanding the value out of data. Yeah, so Athena is a basically interactive query service to analyze the data use onto the S3. So you can use the SQL uh, to process the data. Yeah, so to query the data. It is a serverless. S3 is a serverless. Basically, you do not have to manage anything. AWS does. You just bring your data and put onto this. And then there is EMR, which is a cloud native service for big data platform. It is a managed Hadoop cluster for you to process, analyze your data. Yeah. So if you remember, we talked about it's very essential to bring data, bring all of these resources of collection of data at one point. If mostly, which is the circumstances, if it's not onto the cloud, not at one platform, you have to stitch these things together, which will take a lot of your time, your administration task, and in between you might lose a lot of values of data as well. So having at one place, for example, you can form your lakes as well of the data, lake formation. So data lakes onto the AWS being formed on top of S3 using the AWS lake formation. So you can do that. And for the ETL, you can use the Glue, which is a serverless service used to extract your data, transform, and then you load it back. Yeah. And if for the visualization, you can use the QuickSight as well to visualize the data for business intelligence as well. And then there is a Redshift. Redshift is basically to query the data. Also, Redshift Spectrum you can use, which is used to, it's a, by the way, data warehouse, but you can also query the data directly from the S3 in the data lake as well. Yeah. So this all can help you to build a data platform, which we require for the data collection, collecting the data at one place. And on the other hand, data integration, integrating the your ETL process to your forming the data lake and processing, analyzing it, and preparing it. And then next part come what exactly we do in the preparation. So data exploration and profiling. So data scientist project begin with the data exploration. So better you understand your source data, the better you do the machine learning. Machine learning solution would be better if you explore it, understand the data valuation first. Yeah. So typically it starts with desktop tools such as Excel. So database Excel tools you can use, but then quickly moves on to the Jupyter notebook and tools like Pandas or PySpark we use. So in today demo, we are going to use notebook, Jupyter notebook as well. We'll show you how to explore the data at one place. You can explore it, you can refine it, you run your code as well as you can visualize it. Yeah. So then data formatting. So machine learning algorithms having a very precise input and output requirements which you need to format before with your data. Yeah, so data rarely arrives in the form of that algorithm can uh, easily digest. So you have to format in a better way. So in our example, we will also format it first. So we will remove the columns we do not need. We need to change it. Some of the columns we need to change it to the categorical to another type of it, so system can understand it. So make it right format, which typically comes in data conversion and encoding, where you in encoding basically they are you encode the data. Categorical data must be converted into numerical values for ML algorithm, which you will do. Then data cleaning, what is required, how many columns are essential. Less noisy the data, the better the ML model would be. So you have to reduce the noise. Yeah, so that's the data cleaning, removing the noise, the values which you can remove, eliminate before the training as well. You will be doing in this part. So next come the normalization. So example of normalization is data recalling. So model train best when numeric features are normalized to a range of a minimum and a maximum value for the data set. So example for that would be consider a home feature. So prices can range into millions, whereas number of bedrooms and bathrooms are usually less than 10. Right, so when you are predicting home features and everything, so when processing the on the other hand, when you're processing the images, batch normalization of RGB values will help you to dramatically improve the accuracy. So you normalize the values within your features and data available. Sorry, resampling, oversampling. Yeah, coming the next part, where is a technique to modify the unequal data classes to the create the balanced data sets. Oversampling is a generation of synthetic data based on an original data set to improve accuracy. Yeah, and undersampling is used to reduce the amount of data if data collected is larger than the ideal. So yeah, sampling between the data you require. So very much you play with the data in this section in the preparation part. And who helps here basically, as we have seen in previous slide, data scientist, big data engineers who works on the data cleansing and data making the most value. Okay, so how you can help? You can help by determining, understanding uh, making understanding with the data. If it is a structured data, if it is unstructured data, cleaning that up, uh, understand where data comes from and how it is used today, where it to be restored, and when it should be streamed into the system or it should be downloaded. You have to make an understanding with it. Yeah, so that's where your data scientist would shine. Yeah, that's how you can help your customer as well. And now bringing back to our sample here. So now I would pose some of questions back to all of you, but before that I just want to call it out that data is made up of two main elements: features and labels. Both of them you can see on your screen. So feature is an attribute that can help to that can be used to help identify patterns and predict feature answers. So these all are features you can see here around what is associated with your data. So these are features, and you have an output which we are going to use as a today as a supervised learning. This is our label. If it was fraudulent, if it was not fraudulent, is mentioned here. Yeah. So now to everyone, if I ask you some questions about the data is what do you think? Which type of data is it? Is it a structured data or it is an unstructured data? So by the way, it's an easy one. So I'll just say it's a structured data because data is arranged in a tabular form like a relational database or CSV. So yeah, it's a structured data. And so do you think all of the records have common fields? Yes, it does. It has the common fields around it, like the person who has purchased it, policy, car, model. A lot of values are actually having a common fields. What else? Yeah, by the way, most of the questions I have asked previously, so we can pretty much use this data for the for running our machine learning models, right? So now next on, I will be putting some questions how we can use our machine learning stack. So to making an understanding with the machine learning stack, let's start with the deep learning images, Amazon machine learning images, also called as a DLAMIs. Yeah. Okay, so we will start with our infrastructure as a service, where we have EC2 instances available for you to run your machine learning. So we talked about what type of customers typically use it, who customers basically who have a ML expertise in house. They can go for the machine learning images to start with their own infrastructure tools, templates they need for these two instances, and all and all. Okay, so deep learning AMIs basically for the machine learning practitioners and researchers gives you the infrastructure and tools you need to accelerate your deep learning in the cloud at any scale. So yeah, so these images are templates that contain software configuration you need. For example, operating systems you need, your applications, your softwares, using the machine learning EC2 instances. So everyone who are maybe first time hearing the word EC2 instances, EC2 instances are basically the virtual machines. So deep learning images can help you to run onto the EC2 instances. So you can run your models. You can create your own machine learning I would say workspace. Yeah. So what are the capabilities available? We can see the whole stack here. Deep learning images are available. Basically, two types of deep learning AMI with Conda, deep learning base AMI as well. I will show you in console very soon. Yeah. So you have infrastructure available already to run your algorithm already in built. You can go for that. Or these are the EC2 instances types available. So just forget about it. We will come to that. So yeah, so P3 instances, C5 instances, and if in case you want a very high compute, you need a field programming gate array, you can go for FPG as well. And this very specifically, we talked about new chip types we launched for your inferences. You remember build, train, and deploy. Deploy is about inferencing where you can use these chips. Yeah. So by the way, you have to do it everything all yourself. So, but infrastructure for you available, which is scalable, and having the infrastructure frameworks you require to run your machine learning model. So who does use DLAMIs? Machine learning experts practitioner. They build everything from the Jupyter notebook to the machine learning training um, instances to deploy it for the inferences. Everything experts can do themselves to support all those use cases, like of in the space of learning and learning about deep learning or app development, machine learning, data analytics, or research. You can pretty much use DLAMIs. Yeah. So it would be good if we can find those EC2 instances in our console. So very soon I'm going to launch console for you and show you what are these capabilities available. But I'll take this opportunity also to showcase some of the other services. Will not uh, dive into, but this is, by the way, the console of AWS, where we have more than 175 services, as we call it. And this is this machine learning vertical. You can see this category has a lot of services available. Yeah. So we need infrastructure, EC2 instances to run our own machine learning. You can go and find your deep learning AMIs, which are already consisting all of the resources you require to run your own framework, to run your own ML models. So if I search for the AMIs are the machine learning image, basically a package of softwares available already prepared for you. So you can find a lot of, let me see, by the way, your view, because sometimes it does take time to reflect at your side. So I will be in sync. Yeah, so you might see now there are deep learning AMIs available, which you can directly select and run P type, C type, or another type of instances with these AMIs. So this package of OS and other softwares, basically you are selecting here Ubuntu with deep learning capability. It has MXNet in it, TensorFlow, PyTorch, all other frameworks are installed already, so you do not have to uh, go and install them explicitly. Yeah, so you can use it. So these are configured with Neuron, NVIDIA, Kudo, and there are other Docker, and NVIDIA Docker is also compatible with it. And yes, this is fully managed experience if you are using with this SageMaker. So this is coming with the features, and there should be base EMIs as well. Yeah, there it is. So base EMIs doesn't have the frameworks into it, comes with a foundational platform only. So once I select that, then I can go for, yeah, from there on you can see there's a machine learning instances I can use. So just a second. Yeah, you can see Inferentia for the inference, you can use it here. And if in case I want to use GPU very specifically, I can go for the GPU. G type is available here, and P type, you just need to launch with it. So what is the DLAMI? Is the package software for you to run your own machine learning practices for different use cases, as we can see on this slide, creating your own machine learning model, your own space, your own everything. So for that, you need the whole life cycle knowledge, right? And again, you have to stitch a lot of things together, from the storage coming as well in playing a big role as well. Yeah. Okay, so but what are the advantages? Is in a very animated slide you can see here. Cost and savings. AMIs are free for you to use, and customer only pay for the infrastructure you are going to launch it with, right? And benefits are gained from using powerful compute instances. We talked about it. P3 instances speed up the training and reduce the cost. And yeah, one thing I should say, that machine learning is a lot of compute. Like for training, a lot of compute is there. Yeah. So because it runs a lot of different patterns computing on, That's why you would need more GPUs for your training, for your inferences as well. So that's where these fast running instances can help you. Anaconda Data Science platform simplifies the package. So already you are getting a package softwares, and customer can containerize their code to realize economies of scale as well. So you can containerize as well. And those containers can run on SageMaker as well. We will cover that part. You can bring your own contained models. Okay, so knowledge check, everyone. So Conda based, we've seen some of the DLMIs were having the Conda. Anaconda based AWS deep learning AMIs come with installed Jupyter notebook loaded with which of the following kernels? Yes, so it comes with the TensorFlow and MXNet as we have seen there. Yeah, so I'll just be very quick to answer that. So yeah, it comes with the TensorFlow and Apache MXNet. So right answer is C and D. By the way, with that, it reminds me that TensorFlow is a Google's product, but on TensorFlow, more than 80% or close to 80% of the projects running in the cloud is running on AWS using TensorFlow. Yeah. So yeah, a lot of customers are using it. With that, now let's return onto our any company use case. Remember, guys, we are trying to help someone with the determining if new insurance is going to be fraudulent or not. Do you think cloud DLAMIs or deep learning AMIs can be used to predict future insurance claims? Can we use it? Yes or no would be considered as an answer here. So those who saying no, I might put them question back. Why? Because why not? We can use it pretty much. But yeah, you are. I think you are thinking on the same lines I am thinking. Like that would require a lot of efforts. Yes, a DLAMI can be used. It requires a lot of challenges to manage the solution in the long run, like bringing the data, stitching it, then require deep expertise to implement each and everything. So yeah, we can use it. That's all. That's fine. Yeah, we need to. Uh, yeah, we need a lot of management in that regard. Okay, so now we are going to get into our SageMaker concepts. So what are we going to do in here? Uh, we are going to identify what SageMaker is and how it works, and identify the key components and features of SageMaker. So SageMaker considered as a platform available for you to run the machine learning. Describe the typical machine learning workflows and summarize how to accomplish the task with Amazon SageMaker for setting up or managing the notebooks, training clusters, connectors. What do you need to do? Yeah, so we will see that. Compare SageMaker to the DL AMIs infrastructure to the platform. We are going to think in that direction and identify the advantages of using the SageMaker. Yeah. Okay. So what is in the ML process? So ML process is now we are going to have a look onto that. So first is the model training. Yeah, once we have data, everything with us, we formed, cleaned it up, we visualize the data, analyze the data. For that matter, we use the notebook environment, which can help you to run the codes in a different language it does support, and typically use Python, by the way. Yeah, and you can visualize the data like in a 2D 2D plots. You can have a 3D plots. You can use different tools for that, and then you start training cluster, writing data connectors, like connecting with the S3 and EFS. If in case you are using a machine learning on platform, you have to connect the data being written into S3 or maybe EFS. If EFS is typically used, EFS is a network shared storage, by the way. When do you use it? When you need a very faster access to the data uh, as compared to S3. But yeah, S3 is a typically we use it. Uh, yeah, so you have to write the connectors, scale ML algorithm to large data set. As it is expanding, you have to uh, scale your ML algorithm as well. Distribute the ML training algorithm to multiple machines. So as your data sample increases, your training model require more computation. You have to scale it in a multiple machines as well, right? Because it's a lot of compute, guys. It's a not just a so CPU was doing it. So you need a GPUs first of all. So a lot of compute for training, and then secure model artifacts. So you ultimately have to secure that, place it somewhere after the building the model. You have to store it at some place, and you obviously you have to stitch everything we have talked about all together. And then in that, you have to next step, you have to set up and manage the inference cluster. Once you have a model developed, you have to put the model somewhere so it can help you to make the predictions, right? So what we have considered, this is by the way study, 50% of the models never make to it the deployment due to training and prediction inaccuracies. Yeah. So yeah, you can understand how important it is to have a right training and prediction done. So 50% of the models never reach to this stage. Once, if it is been lucky, yeah. So we have to set up and manage the all infrastructure for the clusters for inference, manage and scale the model inference APIs based on to the users. Yeah, we have to scale it out, monitor and debug model prediction. As mentioned, it is most essential part as well. Now to understand if our inferences which are made are still relevant or need some changes, we have to monitor it, debugging it, or maybe we have to go through all the pipeline once again, track the performance of the all model, all inferences, and then version model in continuous integration. Yeah, so you run the A/B testing as well, automating the new model versions to promote into the production. So if there is a new model with the new data come into the picture, you require, you can uh, you can do that. That's mainly the part of DevOps. Yeah, so there is a lot of different parts need to be brought up together to get the things running in the world of machine learning. So that's where we put the question, why SageMaker? So now I want you to consider the whole pipeline for a minute. You can see the whole pipeline here, starting from the business problem and ML framework. After that, each phase has a task that need to be completed successfully to proceed to the next phase. Yeah. So one of the first phase or first task is to collect and prepare training data, determining which element of your dataset will be important. From there on, then you must select the algorithm and select on your approach. You have to find the right algorithm and then you get started with it. You train the model to make prediction, and after you train it, you tune the model as well using the parameters and hyperparameters, right? Which is often a very tedious and very manual efforts as well. So you could deliver the right predictions. So after you have developed a fully trained model, yeah, you need a all new process to get it deployed, the fully trained model to be deployed. You need to integrate the model with your application and deploy this application on infrastructure that will automatically scale. You have to take care of stitching the things together. You have to take care of the scaling the things together. So all of this takes a lot of specialized expertise, access to large amount of compute and storage, and a lot of time to experiment and optimize each part of this process. So with that said, it's a no surprise that whole thing feels little out of the reach at some point. So that's where the SageMaker comes as an IDE, I would say. So SageMaker is a service that will help you to manage this all complexity to stitching the things together, bringing the data collection onto the S3, then doing the training and modeling everything. After the modeling and also deploying it, right? So these all are recurring administration steps which can pile up and create a lot of delays, and that can get away with the SageMaker. So you could only focus on machine learning problems. So I will track back to the question was asked in the chat before. Do I need a whole expertise? Yes, at some point you need expertise. You don't need to understand the pipeline, but you don't have to be a very hardcore PhD data scientist or something to get the things thorough as the way. Yeah. So SageMaker can be the answer for it. We will dig deep into further. We will have demos as well. So that's why when I ask you once again, why you need SageMaker as a platform of choice rather than directly going to the DLAMI if you are not machine learning expert, because of these reasons. Yeah. So SageMaker has lot of new features came up with this year. You can see on your slide. So from labeling, which is to label the data. Yeah, we'll come to that very shortly. To building, training, tuning, and deploy. Like SageMaker Studio is there, Autopilot is there. By the way, I just want to say that everything which is with the golden mark is all the new services we have launched, yeah, this year. So many of these tools in we use like in traditional way, like IDE we use for like Visual Studio to do our coding. We created a studio for machine learning for doing all of those stuff, project management, collaboration, monitoring, so forth. For the machine learning, this is the one-stop shop for you. By the way, for more on the machine learning, machine SageMaker Studio, we will coming next. So I just want to now move on onto the SageMaker ground truth, but I think it would be right time to take a small break as well. It's been an hour, me speaking, making you to sit on your chairs, sofas, anywhere. So guys, get up, take a walk, or maybe it's a time to do 5 sit-ups or some push-ups. Okay, or so let me just put a timer and we can catch back in 7 minutes, guys. So talk to you in 7 minutes. Have a good break. Okay, guys, we are back. We are back. So just give me a second before we resume. By the way, uh, we are not going to record this session. Somehow it started, and I just have stopped. So by the way, we cannot do share it with outside. So yes, so to answer your question, some of you might have asked if we can uh, share this recording. There's no procedure for that, so we are not going to do that. Okay, so now moving on, what we are going to, yeah, so what we are going to discuss now is Amazon SageMaker Ground Truth. So let me see if you can see my screen. Yes, you can. So Ground Truth, if you remember on the machine learning pipeline, once you are through your data processing part, this would be the first step to label the data. Yeah. So for labeling the data, it's a labeling in itself is a very expensive step. I would say a very expensive stage and time taking uh, as well as very costly as well. So with that, for that matter, we have our one service called as a Ground Truth, SageMaker Ground Truth, which can help you doing the labeling of your data. So I want you to think this way. I have taken some of example like determining a car's picture, if it is a car or not. For that, you have a sample data, right? You have to have a sample data beforehand, which has actually found some of the picture or labeled some of the picture or given as an output of some of the picture. Yes, this is a car. So that's been done how? By the labeling of humans, right? It requires a lot of efforts. If it is a 40,000 picture, now you can imagine you have to do it, label each and everything yourself 40,000 times. Yeah. So for that, I should have sent you one link in the chat, but afterwards I'll send you one which you can see how labeling is being used by one of our tool. So back to the SageMaker Ground Truth. So this will help you to do the labeling automatically labeling by the way of machine learning. I sometimes consider it as a, have you seen this Inception movie? So basically a dream between dream. So it's a labeling between the automation of labeling, machine learning between the machine learning. So yeah, we will see in the next slide how it is happening. So easily integrate with the human labelers. Human labelers, for example, uh, for labeling, you can hire external workforce as well. If it is not a confidential data, you can hire the public workforce. So Amazon, it's a mechanical turk. We have our own one crowdsourcing services available where we have around 50,000 freelancers which can help you with the labeling of data. If in case it's confidential private data, you can have build your own team which can help you doing this labeling in this, or you can go for the third parties. Is it mentioned somewhere? uh, Public private sub, yeah, so it's a private one, third party as well, which has NDA signed with and can help you get the labels done on your behalf on some charges. Yeah, so yeah, you can get it done. So with the best labels, right labels, you get the accurate results. So labeling is very essential. We'll see that. And how does it work? So you have raw data, which could be images, text, speech, or anything without any details of what is inside the text as well. So, so what is the first interaction is the human annotation. Yeah. So ground truth selects the small set of data. First, you do the human annotate it. Human would label the data. What it does for all the data, it will prepare in an active learning model. So, like I selected I selected 100 picture as a cat already. So it will create a model for that machine learning and machine learning. So when next time I put a picture of a cat, so I don't know why all the time whenever we take example of picture, we choose cat. So whenever we do that, it will automatically label it further, automatically annotation. So if the confidence is enough to automatically annotate it, it will send it to the training data. If in case confidence is low, it will again send it to the for the human annotation if the picture is blurry, not clear, or cat is might be sleeping, right? So you have to do the annotation itself. So most of the part has been already been taken care by the active learning model prepared by the ground truth. So it saves around 70% of your cost. So it's an amazing service for you to help with the labeling. Yeah. So now once labeling is done, let's leave that part aside. Now here we need to understand the SageMaker life cycle. Basically, that's what SageMaker does use. It's a fully Dockerized life cycle. We are using containers, Dockers totally. So once you explore, analyze your data, you are ready to build your model. So first step, after the training data, you remember, you have cleansed it, formatted it, encoded it, you have encoded data, you have a training data. And we have today with us training data of 100 samples of fraudulent for an insurance company, and we have 39 features, means 39 columns. 38 features, one was label. So training data is there. So once SageMaker will take the training data, what does it require, guys? Machine learning is all about algorithms. So we need an algorithm. So it has inbuilt algorithm which you can choose. You can bring your own algorithm as well, Docker algorithm in Docker, Dockerized, or maybe you can purchase from the AWS marketplace if in case you think any specific algorithm you need, right? So with the data and training algorithm, next step it brings is the model artifact. So you are left with the model artifact. Once you obtain it, you have to save it. So I think there was a question, I don't know if it was answered. So yeah, on the security. So you can, first of all, SageMaker in itself can be housed between the VPC, so already creating it a very secure. So once model is prepared for you, you need to save it somewhere before you deploy it, right? So next step would be to house it. Yeah. So model artifact is prepared, and then as we said, this is for the data scientist to get this step done. Next comes the DevOps. So now you have model prepared, placed onto the S3, you need to use that. So what do you need, guys? Obviously, model artifact in the SageMaker, and then you need inference engine, which will be a Dockerized image. Basically, Dockerized environment you will gain. And then from there on, you will get an endpoint where your users will be interacting with. Yeah. So fully Dockerized lifecycle you can see here. Yeah. And you can even use the spot instances if in case you want to save the cost as well, because it will be running uh, onto the EC2 instances. So I got a message, lost my voice. I'm hoping it's fine now. Okay, so what does it use? ECR as a registry. From there on, it does take the uh, prepared containers and use it with the whole life cycle of machine learning. So iOS, Android, iOS, Windows users make a connection with the Cognito, which is for the SSO mobile application authorization you to authorize you. You can use Amazon API gateway for HTTP, HTTPS connections from there on model to the endpoint, and you can get your answers. Yeah. So if a developer push this to the cloud, their application will access the endpoint. By the way, Amazon, uh, so they will push it to the endpoint uh, by the way of Amazon API gateways. This open source access to the full range of security and control option of the AWS Lambda. So from the security point of view, and Lambda is basically, if you know, it's a AWS compute service where you can write your own function as a service. Yeah. So it can help you further managing servers, including authentication and identity management, as well as the other security features, which you can use it with it. So just to emphasize onto the security point. So yeah, you will learn more about the notebook instances, SageMaker algorithm, ML training in our later part, wherein we will be doing a demo as well. So now here we are with a next question. So what SageMaker is going to help you with? So Amazon SageMaker uses which of the following component, guys? Select all that apply. Might not be the only one answer it has. So does it use notebook instances? So what is notebook instances? To visualize your data? Ground truth? Yes. The simple name was SageMaker Ground Truth. ML training service? Yeah. So it has uh, algorithms already in the SageMaker available. ML hosting service. Can you host your own environment onto the SageMaker? Deploy it. Remember, deployment was the last section which we could do with SageMaker. Building from the notebook, ground truth, all that point, and then after building, you train it, and then you deploy it, and you, in a one way, you host it. So yes, right answer is it does all of that. Good for all those who have answered it right. Most of you have answered one or other, so it means you are going in the right direction. Okay, so now Amazon SageMaker Notebook. So what's that? Notebook is already prepared for you to get access to and get the things done onto the visualization part, run your code, and whatnot. There are a lot of already some of the projects available which you can try out. Yeah. So and we will create a notebook. So this is the first demo we are going to have. So SageMaker authoring and creating notebook, you can create that, access to the S3 data lake, ETL. So yeah, Jupyter Notebook is where you can create and share your document, code, reports, perform data visualization. Notebook also house the frameworks. So let's see. So it's a demonstration, would be good to have a direct look into the console. So I am hoping now you can see the console. This is where we were launching the eSuite instances. Now I'm going to come back, and from herein you can find your recently launched services, and I have selected the SageMaker. Okay guys, so 5 steps here. Ground truth, first one, then the notebook for visualization, for labeling, visualizing, training the data, inferencing, deploying the data, or marketplace for you. So last month it was not there, but it was there, but not in this overview. And now it is showing in here. So what do we need? You want me to show you labeling the data once? Let me show you very quickly so we take a most benefit of this session. You might like to try it at later stage yourself. So you can create a labeling job. You can give it a name, whatever. I'm just skipping that part now on your screen. So you can see for task type, if it is images, you can classify it's a basketball, human image classification, it's a multi-label, human vehicle. You can do the bounding box, yeah, finding a person, yeah, semantic segmentation. Yeah, you can do the tagging on images, text, and you can do it on to the custom if you want to create any yourself. Okay, so that's how you do the labeling, saving a lot of stuff for you. You can put from where the data coming in and where you can post the data onto the S3. So integration with the storage. Coming back to the SageMaker. So that was a very quick demo of, not demo by the way, I just went through seeing that. Yeah, so notebook instances, we are going to launch instance. By the way, once again, I want to reiterate this session is not being recorded and won't be shared. By the way, we will send out you the data for your reference, and pretty much you guys can also do this because some of the services are free of covered into the free tier, so you can try out SageMaker in itself. I'll send you some of I think it's around 250 hours. It is free for you to try out things. There's a certain type of instances available for you to try it out. Okay, so now creating the notebook instances. There are two of them already created but stopped. I stopped it because I don't want to pay for it. So it's good. You have instances you can stop at any point of time, right? So you are not paying for that once you are stopped. Okay, now I'm creating a one notebook instance. So I will be very creative here. You can see with that, I have given a name here, demo A. So that's the maximum creation I could do. So notebook instance type, you have plenty of instance types available. But yeah, for the purpose of notebook, you can choose machine learning T2, T3, or T4. It is optimized for the machine learning. You can choose one of them. I am going to use machine learning medium one. Yeah, and inference, if in case I need additional chips, I would add it or not. IAM role. So from the security point of view, you already have SageMaker role. You can add it. I am just skipping this part. I have already created role. Very easy to do that. And encryption and another point of security you can put into a VPC. So no access. It's not a free soul would be running into the cloud, but you will have the within the VPC. From the Git repository tags, let's not complicate things. And okay, can you create a duplicate? Okay, I've been very creative before as well. So it does say, what was that? I have already a name for that. Okay, so very bad. I just get these ideas only demo A. So now I have a demo AA. It will typically take 3-4 minutes. So my bad, I should have started one of the notebook instance to run my demo. So meanwhile it is creating, I have launched almost, or basically just started another notebook instance. But meanwhile, we can dive deep into what are the other options. So this is pretty much we have selected instance type, ML, lifecycle configuration. You could choose it in there, and ARN is there. Encryption, you can use it. Networking, you can put into VPC as such as on. Okay, so we shall wait. I should have done it before, but yeah, I will walk you through the other parts of this page. You can also train it from here. You can choose the training algorithms. You can purchase from marketplace. Training jobs will be here for you once you run it. Yeah. So you can create your own training jobs. You can see I've been a little busy in last couple of months. Not much, but yeah, a little bit. You can create your training jobs. So You remember what would be that? It would be a Docker images, right? So by default, it is not in VPC, but you can do that for you. So hypermeter tuning jobs, if in case there are any, we will come to the hypermeter as well. High inference for your deployment, models will appear here, endpoint will be there for you. And new feature, augmented AI. So like it's think like uh, ground truth, right? So labels were when labels were not enough, you use the machine learning for that. So this is for the inference. This augmented AI is for the inference. Once your model is created, it require human intervention. You can create a workflow for that as well for your models as well. So that's what it is. A2I we call it, I think. Yeah, A2I, augmented AI. Marketplace where you can buy the algorithms, purchase it, some of them are free of cost. Data exchange is interesting one. Can I give it a task for you to have a look into that? What is data exchange? Okay, what about our notebook instance? Is it in green now? Both of them are up and running. I don't want to pay for one of them, so I'll just shut it down maybe later. So right now, let's not be frugal. Here we have two options: open Jupyter or you lab comes with more options. So let's use the simple one. So now in a web based, as you know, Jupyter notebooks are web based. You have opened a console. From therein you can see you have nothing running. So you can see if there is any terminal running, cluster running, SageMaker examples for you to try out things. We could take one of them and show you the whole procedure about how you can use a linear learner using MNIST. We use it typically in our demos, but what I'm going to do is just walk you through different things. So these are the Conda environment. You can see what it has a package installed already. So in short, nutshell, things are available for you already prepared. You can create your own notebook, write your own code, what it can do. I'll just very quickly showcase it to you, this prepared environment. Uh, okay. So, for example, what you can do, you can code, you can mark down things, you can put a heading. For example, what I'm going to do, I'm not going to write a code, I'm just going to mark down demo. This is a demo. So, what you need to do, shift enter, and here I need to write a code maybe. So, let a code in the I selected Python, right? If I'm not mistaken. So, I can do print. This is a demo. So, what I need to do, enter. So at the same time, you can put your context, you can write your code, you can do many things, by the way. You can even bring the graphs itself in it. Yeah. So you can install a different libraries and you can do pretty much a lot. Graphs, 2D, 3D, you can 2D, I think, yeah. So you can do that, pretty much it. And you can extract it, save it as a Jupyter notebook. Like think of like whole machine learning life cycle you have created here. Once you have a model, you have to create it, create a training environment, and all of everything. Even endpoints you can launch it using this. Okay, so I am going to stop this. So this was a very quick demo. By the way, we are going to use it in we are going to use it in one of our demo coming next. So you can see I have a Python library created here, which I can use once I have a lot of code running on this. I can show it to my boss, like what are the visualization, how it would be looking like, and everything, all the information. By the way, for you to try it out, try this. Many projects are available. Some sample notebooks. Yeah. So one thing I forgot to share with you, which I would have. Yeah. Just try to use this MNIST one. This is a easy peasy model for you to try out if you want to get hands-on onto the uh, learning the linear learner as well as how say notebook works. So one thing I forgot to mention was once you run enter shift enter, it shows a asterisk here. Meanwhile, it is running the code, right? So by the way, I you can see here I have written everything about. Not I have done it, by the way. AWS has samples introduction. What we are trying to do. Once you will be trying things around, you can create your own instance, notebook, and get the things done. Data ingestion, data inspection. So yeah, you have done in pretty much of it. What I'm trying to see here, if there was anything on the graphics available. So I think data inspection, where should that be? Data digestion. Yeah, don't worry. We will see that in our coming demo. So pretty much it can do a lot of things. Yeah, you can see very specifically I want to call out, you can launch your training environment from here. You can see estimator is would be the command for that. I am launching MLC for X large type of EC2 instance for what we are doing here is basically training the linear model. Yeah, so in the initial part I did what? I did some cleansing of data, yeah, some visualizing it, and then after validating, I would deploy it. Yeah, you will have an endpoint and you can clean it endpoint by this transaction. So yeah, so in short, Jupyter Notebook is the place where you can use your machine learning models, visualize it, write your code, and do pretty much a lot of things. We are going to use it in our incoming demo. I'm hoping we went to depth of what Jupyter Notebook is, and in prepared environment onto the AWS, you are getting them yourself for you to try out things. And you stop it when you don't use it. Why do you pay for it? If you are managing it yourself, you might end up keeping one machine for the Jupyter Notebook all the time. Yeah. Some of the things I need to be careful of. Oh yeah, it is going to get into a lot of trouble because there is a lot of files. I should have done it. By the way, if in case onto this point, now it's too late for deleting it. It's already hanged. So you could get the CLI access as well. So which one I used? This one. So I'm just gonna stop that. It is not going to be used. Let's stop it. Already showing me the error. Okay, since I have stopped it. So for the next demo, we will use this one. I named it a scikit. Okay, guys. So any question onto the notebook, you can put into the chat box. So SageMaker Notebooks demo outcomes, identify where to find SageMaker examples. I showed you. We used one. We had not gone through all of it, but yes, you can go yourself, try it out. Identify which ML framework are available. There are a lot of them. Explain how to access EC2 instances through SageMaker Terminal. There is terminal, you can get it before it could get into hang state. So you can go to the CLI and get the access of EC2 instances. So how to start and shut down instances? Yeah, it's a pretty much easy one. Yeah, no need to showcase that. Okay, so to avoid unnecessary charges, what you should do? I'm sure you would say likewise, because it says you should shut down your notebooks, active processes. Yes, you do that. That's a easy one. So I will take that before you answer it. Okay, so not we are going for the lunch. This is, by the way, for the time if we are going to run it in a different time zone. So I thought I would take a lot time, but it turned out to be very good cycle so far with the time frame. So we are fine, but we will certainly go for the lunch in next 1 hour. It's at 12 o'clock in India, so it's fine. I will share this video as well with you. So what this tells us that we are very much on time. And next is Amazon SageMaker built-in algorithm. We are going to try it out. So what we are going to do here is the objective here is to identify and explain the purpose of Amazon SageMaker built-in algorithm. Locate Amazon SageMaker algorithm examples in the console. Don't worry guys, I have showed you where you can find the algorithms. But once again, I'm happy to showcase here. Select the appropriate algorithm for a business problem. You are going to help me. We will have a game show. So configure and initiate a training job. Jupyter Notebook is going to help us, but pretty much you can do it from the console as well. Associate a training job with the appropriate S3 and use queries with the model. So we are going to do that. So what are the algorithms? Everything in the machine learning is going to be helped by the algorithms. Machine learning is all about algorithms, which are the standardized method that machine learning uses to train the models. Yeah. So model is a function that maps inputs of data to set of predictive outcomes using algorithms. So lot of images to a model. Model tells which one is cat, which one is a dog, which one is a human. So yeah, so that algorithm, that function will help you to determine that. So algorithm helps to create that computations. The exact definition of model is unknown. Okay. So existing data is used to build a function using rules, and this is called a training. That's where we train the data using different algos. Algorithms defines the model rules. What are what are the algorithms? So algorithms, linear regression, logistic regression, clustering, vectorization, image classification, there are numerous algorithms available. And onto the SageMaker, already more than 20 around now, I think algorithms are available for you, nearby 30. Yeah. So you can, for example, image classification, if I specifically call out for, so you can use this algorithm to classify images. Yeah, so it's a type of supervised learning, like pictures, we use it. Encoding and decoding, voice change, NLP, it's like a natural language processing. Understand the context, sentiment, that's where you use the encoding and decoding. So different type of algorithms going to help you. These are optimized or prepared to run the different types of learning. So SageMaker algorithms, which are already consistent to it, these all are provided into the console, a number of built-in algorithms. So most of these are engineered to take advantage of GPU computing for faster training times. I think there was a question around GPU as well. I might have answered already. Based on to the type of data and ML problem, customer can choose which type of algorithm fits their example the best. Yeah. So if in case customer has a numeric data and wants answers that predict a quantity variable or regression, it fits record into discrete category or classification. They can use what? Numerical or classification. They can use a linear learner. They can use XGBoost. XGBoost is typically when you have a lot of features, right? So a lot of features and only few of them are important. So that's where the XGBoost is important. So you have to understand the nuances around it. So more important would be the features which are need to be highlighted, right? So there is a k nearest neighbors, or we call it as a KNN algorithm. When there is a high dimension features, like 100 of features in a data set, usually it's a very slow because of its use high dimensions, a lot of parameters in there. Yeah. So this is basically the curse of dimensionality, we call it. It's the laziest algo. Okay, so then we have other algos. recommendation. You use a factorization machines for recommendation engines, and then group entities. You use the k-means to detect anomalies in a time series data. You use RCF, random cut forest. Specific use cases, pretty much clear here. Classifying images and objects in images, you use image classification. Object detection, semantic segmentation, that's what you use it. Yeah. So if a customer has a text data, want to classify and code, that's where you will use this algorithm, and these all are available onto the platform. I want you to spend some time, maybe you take a screenshot of it, if because once we will be taking a uh, quiz coming in the next slides, might help you to answer it. But I will be your host as well as your host to help you guide the answers. So predict future trend based on to the past history. Use a deep AR forecasting time series. Yeah, reduce dimension PCA type. You can use it. So basically, you use these answers to simplify view of current and prospective customers. That's where you use a PCA type. Find usage patterns in network access logs, IP insights. So these are all available for you onto the SageMaker as an algorithm for you to train your models, to prepare your models. Yeah. Okay, so let's play the game. So I am your host, not I'm Mary, I'm John. So we are going to get through the algorithms. Game show, there are three scenarios related to Amazon SageMaker algorithms, and you need to choose one of that four options. One of the option or among the four options. Yeah. So first of them, easy one. It's a organization which would like to predict the price of home newly listed onto the market. To train the model, you want to use a real estate dataset with 1 lakh records of selling prices of house in that area. You have already a dataset of 1 lakh records. Dataset has a 12 features. Which algorithm do you think is suitable? Okay, so mixed answers. And and linear learner is dominating so far. So I would just cut one thing, since deep AR is coming as an answer as well. That is specifically used to predict the trend on a time series dataset, which is not the case here. So guys, we are not going to do that. Deep AR. RCF is mostly used in classification. So no, not factorization. So we are going to use linear learner algorithm. So the right answer is linear learner algorithm, because dataset is very small, right? Oh, sorry, features are very small for you. So number of records and features, yeah, records is as well as not that big. So linear learner is the best suitable. Next one. Don't worry, you have 5 more chances to get the things right. So now there is a home insurance company which is going to uh, what exactly this scenario is. In the past, it is estimates for rebuilding a house has been a manual. What exactly is that? Estimating rebuild a cost that has been very manual previously. Yeah. So on a variety of factors such as house price trend, interest rate environment, labor market condition, price index of the house, many other features of the house and location. Now your company wants to automate this whole pricing thing using the historical data. So although there are hundred of features to consider, from the prior experience, you know that some of the features are more important to build the home other than others. So if you remember, I talked about one of the algorithm where we focus more onto the features. This the one where we are going to focus more onto the features as compared to the others. So XGBoost is the right answer. So that would be the most optimized one to use. There are answers. KNN is used. KNS would also likely to suffer the curse of dimensionality, as you remember. KNN would be very lazy, very slow down here. So to focus on to the right features here, XGB would be the right answer. Good job, everyone. So moving on. Third scenario, National Bank. So National Bank that has been risking scoring their clients based on the various parameters such as demographics, product used, transaction types, and so on and so forth. Yeah. So risk scoring algorithm they have been using so far is based on hand coded business rules with more than 50 inputs parameters. Now they need to classify based on the similarity of parameters. Yeah. So what do you think? So answers are coming random cut forest. One of them was there. That was to puzzle you, by the way. Yes, RCF is one of the answer, but that's not suitable because RCF is more suitable to detect the anomalies between the data set. Suitable for the cases where few points have much higher distance from a common cluster than others. So, right answer K means. So, good observations who have answered it K means. So, because in this case, bank just must identify a prominent grouping present in the population in the demographics, which make K means clustering the most suitable here. Next one, quickly we'll go through that. Credit union, basically that lends the money to individual. In the past, they based their decisions solely on the individual credit scores. Now, over the time, they notice that the credit score alone is not enough to accurately predict the individual chances of defaulting onto the loan or being late onto the payments. So they have collected data from the past on individual age, demographics, family status, income, net worth, and so on and so forth. Now, the data along with their history of payments, in default, they group the people into 5 categories from moderate to high, low, medium, high risk, and they want to predict which group of potential borrower fits into. Right answer, Asta. So we have now answer for that is, so I'll go through why not others. Linear learner. So problem is clearly phrased as a classification because we have to classify by the ages, by getting the group. So linear learner is not there. So K near is the right answer. Why is that? We'll come to that. Why not others? K means no. Yeah. So on to the other one. XGBoost would overkill since you do not need to accurately predict the continuous target. You are not using that. K nearest mean would be the right answer for it. Yeah, so good. Right answer. So last one or maybe second last one. Manufacturing company, very quickly making 10 valves, product built in random order, need to be classified for labeling and packaging, need to automate classification robotics using AWS IoT. What do you think, guys? So one thing I have not emphasized on, so they need to, yes. So even though not emphasizing you are giving the right answers, we need to go for the image classification. So object to vec, as most of you having answered in there, has nothing to do with the image analysis. It is basically lower dimension embeddings from a higher dimension feature space. So it's often used as a pre-processing for the other algorithm. So object to vec has nothing to do here. It's a image classification is the right answer. Okay, with that we are done with the game show. You can hear some of the clappings at the background, all virtually. So that brings us to the next point. So my question here comes again. We had structured data, we had a lot of features, one label as well, and this is what we are going to use today. What do you think? What can we use? Which algorithm we can use here to address our machine learning problem? So lines are open for lines. I mean by that you can put into the chat and question tab. What do you think shall be used here? So answer must be coming in. Let me see the question tab. Yes, linear learner. Yes, right, guys. So it should be linear learner for you to have a look. This would be the sample data we are using. So you are just seeing the synopsis of it. Where you can get this data, I will send you a link for you to try it out. Yeah, so it is provided by our one of our partner, Databricks. So you can find. So there is a lot of features, right? So a lot of features, policies, and we have 39 columns. There's additional one which we will remove. Oh, yeah. So yeah, so that's the data we are using. Control Shift up, and I just better stop it. Okay, so back to our slide. So this is a data you can see. So which algorithm we can use is a linear learner. Yeah. So data is here referred to as a um, in a different segment features. We are going to use linear learner. By the way, we can use other XGBoost, K nearest neighbor, known as a KNN as well. Yeah, we can use them as well. I can see a lot of answers are coming. So we are going to try the linear learner, by the way. Okay, so moving on. So how can you help to understand your customers? We will demystify how exactly, why exactly things. I can see a lot of questions coming in. So how you can help your customer to understand the data structures and understand, by the way, linear learner, we have the uh, fraudulent with us. We know what exactly the uh, label is going to be. So that would be the choice we are going to make first for try out things. We can try different algorithms for sure, but we are beginning with the linear learner. We'll see in the demo what we are going to do. So let's leave for that part. Okay, so how can you help your customers? Further on, as a partner, guys, you're gonna help your customers with make an understanding what exactly data they need. If it is in a structured way, not structured way, helping them with that purpose, determining which algorithm based on to the ML problem. You might try multiple algorithms to find which are the right answers, which we are going to do. We are going to try out different ones as well, different grids as well. So Amazon SageMaker dev developer guide is going to uh, you can guide your customer towards the this particular guide to learn more about built-in algorithms. I will also share with you guys so you can have a look onto this. Experiment with the algorithm to find the optimal algorithm to solve ML problems. So every algorithm can give you different answers, different precision, different F1 scores. You find the best one. So that's where we say a lot of compute is used, because many times you use different algorithms to find the right answers. Okay, so next one is, now we are going to do a demo using this scikit-learn. So why scikit-learn specifically, which is, scikit-learn is very lightweight, easier to deal with the data set, and we have a very small data set, so we are going to use a scikit uh, to pass the data. And yeah, so in SageMaker we already have a scikit. It comes with the scikit as well, scikit-learn, for you to try it out. So what is basically our use case? So to get back to the use case, just talking about the background of it. So researchers suggest that insurance fraud cost more than 80 billion a year, making insurance uh, yeah, it's cost around 80 billion per year in the fraudulent only. Yeah, so detecting fraud uses the significant resources and manpower. We have talked about it. Insurance use a big data to address the fraud right now, is one of these snapshot on the left side, but we will cover that in coming section. ML helps to insurance with the fraud prediction accuracy. We will need to find it out how we can do this. And ML to improve the pricing accuracy, loss prevention, and customer relationship as well. Yeah. So many of the things this machine learning is going to address. And how machine learning can help here: to find insurance fraud is a binary classification problem. So detecting insurance fraud poses an interesting problem from a data science perspective. The problem becomes a binary classification problem, is in which response is yes or no, if the claim is going to be a fraudulent or not. It's a classification, right? Yeah. So we are going to demonstrate attempts to solve this problem in our next segment. So dataset has 1,000 sample. It's a very small one, so we might not have the right precision as well, but yeah, we'll see that. And 39 features into it. So what is the goal is to train the classifier and predict whether the claims are fraudulent or not, and you can access the data here. So I will share with all of you where you can go directly and access the same data set for you to try out things. Okay, so now this would be the outcome. So let's not jump the gun and get back to our notebook and try this demo. By the way, we can get the demo done in two ways. By the way, three ways. One is I can run through the HTML where everything is already been covered, or I create everything like an algorithm from here in, creating a training jobs from this section, and then deploy it, or use the already prepared Python in our notebook instance. So let me just open that one in here. Okay, so let me get out of slideshow mode. Okay, so that will not trouble us. So okay, that was stopped now. Did I click on this one? A link I will share with all of you soon. Oh, I have done that 18 hours before and it was not removed. By the way, you can go to the CLI and remove it. I'm just not going to do that right now. So what I'm going to do is upload a new file. I hope this will not trouble in between. Uh-oh, I cannot drag it from here. So we can use this one at first. I upload, where is my data set? Insurance claims. Okay, so I upload that too. So let's open the Python. The font is too small. Let me zoom in. Sorry, guys. By the way, we have done nothing yet. So yeah, so in the Jupyter notebook, you can see here, it's a words here, it's a graphics here. You can have the images as well. So it runs us through everything we have talked about. Insurance fraud is one of the biggest crimes in the US. Every year, it claims underwriting fraud cost around 80 billion. Fraudulent claims account for 5 to 10% of the claim, which we are going to predict. Yeah. So annual cost by the way, this is a different insurance claims you can see in the auto liability, auto physical, other liability, medical profession. So it has segregated the whole information. Yeah. So next one, I will also have a look onto the view. So I will be in sync with you while I am dragging things here. Okay. So yeah. So impact to the fraud. What's been the impact? It claims they directly impact loss ratio, thereby reduce. Oh, double click doesn't help you. So it just highlighted. So thereby reducing profitability, also negatively impact return of equities. So they are losing a lot of stuff. Their business need is that control the dishonest claims. What has been done so far? Typically in our industry, they are using the fraud analytics. Yeah, detecting insurance fraud poses a very interesting problem from a data science perspective. As the problem becomes a binary classification, yes or no, claim is fraudulent or not, it would be better to use the machine learning, right? So you can see social media analytics use 25% and 100% predictive modeling is required and being used. What are the data sources can be useful or to be used? Internal CRM system giving the information, claim records, log notes, web chat transcripts, billing of the customers, policy information, many other things. And external, we need the data from the external resources, police records, social media, external interaction as well. So we can use these as a data sources. So now what we will demonstrate and attempt to solve this problem by using an auto insurance dataset containing 1,000 observation. I uploaded a one CSV file and 39 features into it. Using this data to train and classifier to be able to predict whether a particular claim is fraudulent or not. Yes or no, we are going to find it out. Yeah. So you remember we had a 100 rows of data, and last column in that was telling us if it was a fraudulent or not. Using that data sample, we are going to first figure out for all the new records, will this be able to identify if it is a fraudulent or not? So what first is what we are doing here, as you remember, Jupyter Notebook, you can also run the code directly. We are running a codes from here. So this is installing, importing some of the libraries like pandas for data formatting and matplot for 2D 3D graphic showcase, and insurance claim CSV, which I uploaded, is going to be posted in that. So I hit Control Enter. So it shows in asterisk. Right now it is running the command, and when it is shows as a 1, it is through. Now the first segment is coming on to the data exploration. So understand how many rows and columns. By the way, output is already there, but just for the sake of showcase, I'm going to showcase you 1,000 rows and 40 columns. By the way, one of them column is we need to remove because we had 39 features. I think I just created a lot wrong uh, data set, but we can clean it. So that's what we do. So now some of the features have a wide variation of the values. Some features have missing values. This is a mix of numbering and categorical features. So guys, it's now data scientist and our task to clean the data. So to understand from that perspective, let's have a sample of 10 of data rather than looking at all of them. We can find what's going around in the data. You can see umbrella limit is a very disproportional police report. For many of them are missing, might need to remove them. And this C39 column is just a dubious value. We need to remove that. Okay, so it's also for formatting to understand what type of data we do have. We are running data types. So output is there. So policy number, int, object, float. So there is a different categories of data you can find, which we might need to. Why might we surely need to change it? Yeah. So herein we are going to find out basically which fields have a too many categories. So this runs in and we can find police bind date has 951 records in it, and then incident days is 60 as compared to the incident location is 100. So these are having a lot of categories into it, so we cannot encode into a numerical values meaningfully. So we need everything categorical to numerical. We need to encode that, right, to have a data format in a one way. We need to format the data. So we will remove this dominating categorical values. So these are not troubling us with their disproportional values. So we will remove that. So that's what we are going to do. Columns to delete, policy numbers. What are those? Policy number, incident date, incident location, and one of them I will take a little benefit here to remove. What was that? Well, let me just see 339. So that is not giving us any value. So let me just remove that too. And yeah, so we are going to remove these columns. Okay, control enter. Oh, sorry. And real demos, can be sometimes challenging. So far, all going good. Remaining columns will be encoded later. So what we are going to do here, we are going to see the yes and no in a strings column to delete. Okay, so these are the ones not in columns to delete. So next one is we are going to analyze the location of claims in the next. Before that, we are going to see the target variables to be predicted for report. Plotting it now to count of observation belonging to two classes. As you remember, we have a yes or no, which was fraudulent or not. So using the matplotlib libraries, we have seen not fraudulent is dominating around 70%, and yes, fraudulent predicted is here, very small sample. So you might say this can be pervasive challenge because data sample is in itself disproportional. Yes, it is. So yeah, so that's one of the observation from the data sample. If I say we now need to go back, bring more data, since there was some of the question in the morning, when we understand there is not enough data, I think we need more data sample to get at least some of the right proportions where it's claiming that rightly we have predicted, we have found it as a fraudulent proportion around 60, 40, 50, somewhere around, yeah. But we have to settle with this. This is what we have. So now we are going to find data onto the incident. So incidents happen on a state wise. Will this be informative? This will be useful. We are going to find it out. New York, this many has happened. This I don't know, San Francisco, which city is it? So there are different cities. It shows how many incidents has happened. So plotting the claims data on a map, providing now as a nice visual on which area more prone to get the insurance claims, which could prove to be valuable insights. Yeah. So S is South Carolina. So sorry for that. Okay. So next one is to now get these values into states, and then we are going to plot it in a very nice graph so we can understand from where in the which part of the USA these claims have been mostly came from. So we also need to install here, basically just to update here the pip. I just going to run with this. Okay, let's not trouble it. So we are going to graph it in a in a very nice map here. It is still processing, or has it processed? Oh, I think I need to update it. This should show us a graph. Let me just try. Okay, so once we are done with the installation, successfully installed pip. The latest one is upgraded. Let me just try now. Okay, now it's executing. Let's see. Okay. I got an error. So guys, live demo does happen. So let me just bring the page. How would it will look like? So you will have this type of graphical presentation available there. Yeah. So just onto the HTML, I have a fallback option. So let's go back to our notebook. This is CLI. So now this is, so by the way, plotting the claim reported per year shows us no pattern in the claim. So meaning date of claim of likely have not much influence. So that's what we try to do. So I'm going to delete that. And that has run. And the next one is plotting the graph further, which is going to split the data into X and Y, representing features and targets with categorical variables encoded into numericals ones. So this numbers, so after this, now number of columns can go up since each categorical data is going to get expanded. So what we see here, so with each year, we have almost equal amount of claims are coming. So we see no pattern. So I have already deleted that one. Yeah. So that plot. And next, what I'm going to do is now encoding the data, changing the categorical value into the numerical one. So if you remember, we had 39 columns initially. Now once we change it in a categorical to, once we now encode it, now you have 161 columns into it. If I go back up and check this, how many columns in there, data type should be sorry, not data type. So here you will see, should be seeing 1,000 records, but 161 columns. So it's not been updated. Don't worry. By the way, that's the afterwards. Okay, so 161 records are there now. It's saved. Now what we are going to do is try the logistic regression. So the problem we have at hand is now is a binary classification. So where we have to predict observation into one or two class, yes or no, zero and one, if it is a fraudulent or if it is not a fraudulent. This can be achieved using such as logistic regression, which most of you have answered, random forest decision trees, and SVM with the various hyperparameters such as penalty function used as well. So what we are going to do is before doing a full grid search, our first attempt to run is a logistic regression through the whole model, doing the grid search and random cross validation using scikit-learn libraries that are computationally inexpensive. That's why we are using it. So now we are going to run the mm, logistic regression learner. So hyperparameter is L1, L2 already considered here for giving us the better performance or better output. So, so we have just started running the, yeah. Okay, so it has finished. So we have got mean accuracy. So mean and median usually we get as an output. So here with the mean accuracy, we have mean accuracy of close to 88%, which is good, which is fine enough. So this is a result of grid search. So however, you remember we had a very imbalanced classes. Yeah, so in this particular case, as we saw earlier, this is a large imbalance where much of the claims are identified as a not to be fraudulent in training data and one to be fraudulent. If you remember, we had seen one of the graph in the red column and in the blue one. So red being with the yes and blue one with the no, something like that. So it's a very disproportional data we had. So in reality, insurance industry would prefer to predict as many true negatives to minimize the loss. So they have more focus on predicting the more true negatives, not fraudulent. Yeah, true negatives. So we create a classification report to see how logistic regression model performed in a predictive both cases. So let's run that. So by the way, output is there. Precision we have for not fraudulent is 88%, which is good. And there is a one fraudulent, we got around 0.63%, which is fine. So in spite of relative difficult in predicting negative samples, logistic regression still predicts fraudulent claims correctly about 60 to 3%. Yeah. So which is fine, good enough. So even though preliminary test looks good, it feels like we can proceed with the product putting this into the production. With the logistic regression, it would be very prudent to do a search or other algorithm available for the task. So we can try other algorithm. So here we are going to use the pipeline. By the way, and by going one by one in the grid search, we are going to run in a pipeline fashion, like for logistic regression, random forecast, forest classifier, decision tree. We are going to run all of them in a pipeline and see which gives us the best results. Okay, so now to get the mean accuracy between that, has that run? Let me just see. Yeah, it has conducted. So now it is performing the grid search onto the other one. So what did we get as an output here? So it is still running the mean there to determine the mean accuracy of the model. Okay. It's a little bit slow. Meanwhile, can we get a copy of this notebook to try out in our account? Yes, certainly you can get it. I linked you. I will share with you. Guys, can you hear me now? I just switched between no audio and computer audio, which I think shall do the thing. Oh, great. So, good. I was wondering what happened. Then I remembered my old trick moving between the no audio and computer audio, and it solved the problem. So, what we left here with is basically the grid search finds that decision tree classifier to be the best performing among the other uh, models we could try. So, in our data formatting, so we are now having the 86% clearly lower than, oh, sorry. Yeah. So, what it has given, yeah. So, it has given us the accuracy of 86%. Yeah, which is clearly lower than the logistic regression. So, what we had in there, we had there, uh, what was that there? I don't remember. We had there around 88% for negative one. Yeah. So, but again, only the accuracy measure is not relevant to get the imbalance of the data set. So, what we are going to do now, we are going to run the uh, classification report using the identified classifier from the grid search. That's what we are going to run. Okay, this is HTML. So once we run it, it gives us the precision wherein mm, those which are not uh, so successfully fraudulent, not fraudulent, is identified 94% time. So it looks decision tree classifier is a higher in precision, but on to the other hand, fraudulent one is lower now. Yeah, so fraudulent is lower to 59%. So as opposed to 63% we were obtaining with the logistic regression. Yeah. So, what do you think, guys? So, we have considered we shall go ahead with the linear regression as that was helping us to find the negative one accurately, 64%, which is more than more than, uh, yeah, decision tree classifier. So, uh, as discussed, correctly identify fraudulent claims is more important for the insurance claim. So we shall go ahead with the logistic regression classifier. So as a next step with this insight derived thus from here, we will move on further to create a SageMaker training and deployment pipeline using the SageMaker native algorithms using the linear learner algorithm. Yeah, so linear learner algorithm can be used either regression or a classification. So when used for classification, it is essentially the same as using a logistic regression classifier with a lib linear resolver. So that's what we are going to do the next. So here we have stored the whole data. We undermined which algorithm is going to be a better one. We visualized everything. We've seen which columns are more important, where we encoded them. Then further we got 161 columns. The data is prepared for you now. Now it is next job is to run the training of the model. So we will do that in our next section. It is still running the uh, git search onto that, so executing the whole pipeline. That's going to take time, so it's fine, leave that here. We will be doing our next demo, trying the things onto the training side. Either we create a training job from here, but I will be following the notebook. Yeah, so I will share with you how we are launching everything onto the SageMaker. So data is there for us. Now the next job is to model is there now, to train it and to deploy it using the SageMaker. So guys, with that, I'll come back to the slide. And now the outcome of this, like we have discovered which ML problem, discover the ML problem data using scikit-learn. Using that, we find out uh, logistic learner is the right option as compared to the other one, because finding the negative one is more important. Focus on collection, integration, visualization, and analysis of the data locally, determining optimal algorithm, scikit-learn to address the problem, understand using the scikit-learn, saves customers money during the discovery phase. These are the things which you will observe once you will try it. Yeah. So next one is uh, to do the fraud notebook demo 2, which is data preparation, model training, and SageMaker, training the data in the SageMaker. I think we can take the break here, which I talked about in the previous slide. Yeah, so I think we can take a break around 30 minutes. Would that do for all of us? And then we will jump on to our next part by creating uh, machines in SageMaker to train the model. All the Dockerized uh, lifecycle we will identify in this second demo. Okay, guys. So with that, let's break for a lunch for 30 minutes. So let's consider 35 minutes, 36 minutes. We will come back at 1:30. Right now it's 5 minutes to 1. So I think it's ample time for us to grab a lunch. And meanwhile, I will have a look onto the questions you have, which are already being answered by my team. And let's catch back in 35 minutes with the next demo. And there are some questions coming in specifically about can this data notebook files will be shared. You can try many things in the Jupyter notebook itself. If you can see on your slides, it will talk about many things we have covered. One of them you can try the linear learner using the MNIST. Yeah, the whole information about MNIST you will find out, to predicting a word, scribbing word 0 to 9 if it is a, yeah, so images to predict that you can use this one. And yeah, you can try other XGBoot, and if you want to do the object to vector, you can try this out. How can you access the notebook? In your free tier account, you can try it out using the creating it from your console directly. Okay, we'll cover that, Sunny, coming up. And right now, let's take this time for lunch. Catch you in 33 minutes now. Okay, so I'm hoping we all are back. Good. So let's get back to the job at hand. So what we had done in the previous demo, formatted the data, encoded it, ran some of the algorithms, figured out which one is going to help us, right? And to do that, everything was done into the notebook. Yeah. But in the next demo, we are going to use the SageMaker to do those all of actions. Yeah. So let me bring this here. I'll open a Jupyter notebook. So we were trying to find a fraud accurately within our data set, and with a logistic uh, search we had around 64% accuracy with the accurately determining which was accurately predicted, which were not fraudulent, right? And let me just get back to the slides. Okay, so now we are going to do what? We are going to check their data preparation and the model training in Amazon SageMaker. So I will walk you through when I say claimed since morning, uh, like from build to train to deploy can be done from a one point of interface, or basically one platform. That's pretty much I'm going to present now. Yeah, so I'm going to upload prepared notebook. And by the way, there was some of the questions coming in. If these notebooks can be, this Python code could be shared with you to try out things, to yeah, to play around. I'll check that internally and let you know, guys, if you can find it. By the way, what I have done meanwhile, I have shared with you the Databricks link with you, where you can find all that data I am referring to regarding to the uh, fraudulent claims. Whole study is there as well. Okay, now I'm launching a notebook, Jupyter notebook here. So we need to set a kernel. I am choosing the Conda Python 3. Set this one. This is going to help us. So share the link again. I'll share the link once again. So now SageMaker linear learner we are going to use. It's a binary classification. And what SageMaker allows us to create, train a model from managed environment. Remember, I showed you one slide which was very much animated. We were bringing up the model. We were bringing the untrained model first, and bringing the algorithm Dockerized, and then from there in we were getting the model artifact. Right? In the previous section, we have done it manually using the algorithm therein. And then from the next point on, once the model artifact was there, we chose the inference Docker and then deployed it. That's pretty much it was showed in the slide. So how you can do it? So inside of SageMaker, manage containers, the algorithm is there. Yeah, whether you choose the built-in algorithm or create a container with your own algorithm, run in their own execution environment, you can do that. So in case of SageMaker built-in algorithm, they are implemented using MXNet as framework of choice. If you want to build your own algorithm, you can free to choose any framework you prefer. Yeah. So in either case, you can then invoke the containers to trigger training and deployment model using three of the ways. The simple one, console, CLI, or in case of Python, Boto 3. So what we are going to use today here, Jupyter. So Boto 3 is what is AWS SDKs. Yeah. So now first we are going to configure. Yeah. So we are going to configure an S3 bucket to store training and validation data and capture models, model F artifact. So bring the training data. So what is the training data for us? That file, 1,000 records with 39 features into it. Yeah, 38 specifically, and one is a label and validation data. Basically, we run the validation against the model. So once we have a model prepared, if in case there is 100 columns we have, 100 rows, let's consider 100 rows of data we have. If we run the training on the whole model, like 100 of all tables, all rows. So to validate that data, either we have to wait for a new data come in and we run it against in real time, which is should not be good practice. To understand the data value, we take a small chunk of it as a sample data, as a validation data. So we run this validation against it. So machine learning, which has run on to the 80% of data. So typically sometime it is 80-20, or it is 70-15 for sampling, and for validating you can use it. So for validating 20% we keep it. So among the same data which is not trained, yeah, so will not have the same pattern we used for finding the answers from it. So we can run it against it. Boto 3 once again is AWS SDKs for Python. Yeah. So since we are using Python, we are using Boto 3. Okay. So what else? Interface to communicate. So API in S3 to store the data and model artifacts. So right integration between the storage. We are going to use that. So the code below connects to S3. This code here, right now highlighted, is going to connect to S3 bucket, where we will reside the data, create a root folder in that bucket, and subfolder entitled the data. This is where the training and validation files will be stored. So with that, let me also open S3 so we can see what is going in the real time from, yeah. And I also confirm that I do not have any bucket created. Bucket is basically the folder where your data is going to reside, unlimited data which you want in a specific region. Okay, so back to our Python. So basically our notebook. So I select it, or basically already selected. I hit the control enter, or maybe shift enter, and it is now running. Creating what? Creating a session with the SageMaker, importing the SageMaker using the APIs, and importing the Boto 3. Data will be staged at this bucket. So bucket should have been created now in console. Let me refresh. Okay, do I have to refresh the whole page? Strange. Okay. So yeah, you can see the bucket is created with the name SageMaker, US East, the region I was in. Yeah. And next stage is staging, cleaning, and preparing data. But we have done it, data exploration part, using the scikit-learning in the previous notebook we have seen. We have removed many tables. We have done the encoding. So that part is been done. Yeah. So now we need to stage the data in used SageMaker managed training. So when using SageMaker managed training, note the diagram, this one is unlike the previous one, experimentation. So training data would not run on a Jupyter notebook in itself. That's what was happening in the previous one. Yeah, instead now we would be supplying the cleaned up data as in a stage onto the S3 bucket, pointing. You can see there. Yeah. So From there on, pointing the specific algorithm container. So for example, linear learner, SGBoot, XGBoot, whatever you are running a algorithm, you will be bringing it as a container in there. SageMaker will manage the procuring of this training instances, running the training in the distributed mode if in case it is also chosen. So deprovisioning of the training infrastructure and persisting the training output onto the S3 bucket. So whatever the outcome would be, get back onto the S3. I will take back you to the previous slides I showed you in the animation. That's pretty much it is being done here. So we consider the staging the data onto the S3 bucket is the first step. Remove unnecessary columns are we going to do. Remember, we removed the policy number. We ensured JIP, incident location, incident date. That was not helpful. Arranged columns in order. Encode the column into numerical values from categorical to numerical. Yes, we were taking, yeah. So when the number of columns increased to 161, as we remember, one additional step we are doing, all those steps we are just getting it done in one transaction. And additional step we are doing here is splitting the data into training and validation. What will be trained, validated against the same data. So once the cell is processed, you will see the result of building data into two data sets with the number of features and record set. Features and record sets. So removing the unnecessary columns, these were the columns I'm sure you remembered, columns in the grid, and that's where the data is been procured from. Somewhere in the GitHub it's there. Okay, so yeah, you can see that we also dropped the column as well, 39. So I hit enter or shift enter. So yeah, so we are left with 162 features and 800 records. So 1,000 records were there. So those now been distributed into training data and validation data, which we will run the validation against. So next one is pushing the training and validation data to S3. Yeah, so you can also use S3 or EFS for very fast processing. You can use EFS, you can use FSX for Lustre. Yeah, so you can use it. It is compatible. Amazon EFX is a network file storage, where S3 is a block system storage. We talked about it. SageMaker has a capability to use training data stored either onto the MS on S3 or block storage object, or EFS as a file system. But we are going to use S3 for the purpose of considering as a streaming data streaming in. So in this case, we will use S3. Fine. So what is going to happen in this one? Import IO S3 equals to borrow 3D source. So training data will be saved as a CSV file. Yeah, and validation data will be also as this is a validation file, and there is a CSV file as well. So we are going to place the data in subfolder in the notebook, and this is creating a new subfolder will also be created for the artifacts. That's where the output data will go. So we have creating the place where the data will be residing. Training data, validation data, and model artifacts should be the very fast procedure. Training data uploaded to S3 in this space. Validation model artifact, it should not be yet there because we have not trained anything yet. But let's see go into the SageMaker and see what do we have. Sorry, not SageMaker yet, into the S3. SageMaker work is yet to start. So fraud prediction, we have seen now it has integration with S3, created a sample of data, training data and validation data is there. And sooner we will also have a output as well. Once we will run it, it will be into insurance fraud. There will be a new folder named as output. Now model selection, linear regression or logistic regression. Since our initial experiment showed promising results using the logistic regression with the scikit-learn, we can implement the same using the SageMaker using linear learner. Yeah, so we are going to use that, and we are not going to use any hypermeter at first. As far as I remember, we are not going to use any um, hyperparameter, which basically brings the more valuation in our prepared model. So next is to obtain the Docker container image for linear learner algorithm. So remember, we are going to use the algorithm linear learner, and in SageMaker everything is Dockerized. So you will get it as a Docker image and generate unique name for model artifacts. So what we are going to do now, getting an algorithm for that, and it will have a name for that as well. So this has given us an algorithm as a container image in Amazon SageMaker. Next is model training. So before I go to that, let me go back to the SageMaker and come to the algorithm. This is algorithm we need to find. Okay, so training jobs, yet there is none. But what I was trying to show, if in case you want to create everything from the console, that's pretty much you would do. Demo. So what do you want to use? Built-in algorithm, or you want to bring your own algorithm? You want to bring your own algorithm? You choose your own algorithm container in ECR. If you have ECR is a Elastic Container Registry, so where you can bring your or on images, container images, which can be your own algorithm, or you can buy something from the marketplace. So what are we going to choose? Linear learner, right? So choose a linear learner here. That's the image. You can see that's what we created using the Jupyter notebook. Come on, let me come back here. So you can, let me see, what do you see now? Yes, you can see it now. So you can see I have chosen the image URL linear learner. That's all scripted already. Our algorithm container will format and you get a name. And that's pretty much I can do myself using the SageMaker console. So those who want to get it done yourself, they can use it. Input mode file or pipe file not. I'm going with the pipe, basically streaming in more faster. And algorithm you selected will publish the CloudWatch metric. So this is something I would say a lot of advantage over the using SageMaker as well. So you can get the CloudWatch monitor, you can get the logs as well, which is very important to like for finding the objective losses in within your model. It should decrease over the period of time, right? So you can find it, precision, recall. So you can lot of information on this matrix is available. We'll come to that. You can select which for training the model, which instance type you need based on your choice, based on your requirement. You can choose how many you want. You want to expand more than one, you can go for that. And security, you can encrypt everything is happening there. Stopping condition after 24 hours, enable network isolation, more security, and hyperparameters to control the whole training, which adds more dimensions features as well. So you can add how many feature dimensions you want. Yeah, so you can like predictor type here. We are going to use binary classification, multi-class. So you can put the more hyperparameters in here. There's a lot of space you can use it. However, in this section, we are not doing it. So with that, at last, we could create this training job in here because we will put training data into the S3 location. You can see here, which we have created already. But let's not talk much about console and come back to our Jupyter notebook because we are handling each and everything therein. But you can pretty much do it yourself from console as well. Pretty much self-explanatory. So now what are we doing? So we are configuring and initiating a training job, associating the training job with the appropriate S3 bucket. Yeah, and then validating, selecting the desired default parameters, not adding any hyperparameters. We are just using the default hyperparameters. So you can see this is what we are going to launch the machine as we select ML M4X large, maximum runtime in seconds. We have this time. Yeah. So let's run it. Let me see if I'm not jumping. Yeah, not jumping any step. Control Enter. So this process has started now. Going to take some time. Let me go back to the SageMaker and showcase it to you. So you can see now training job has initiated. Pretty much you can try training job and things will be done, but we have done it earlier. So meanwhile it is happening, let me walk you through the console. What are the things for you to have a look onto? You are not going to get stuck with your environment for the training. Once things are done, you just pay for the compute you used for the training time. It is the training time it consumed to train your model. You're not paying anything beyond that level. So it will take around 1 or 2 minutes. You will be paying for that. Think about it. You are creating your own training environments altogether just for the training purposes. Here you have a choice to choose the platform and run the training. Yeah. So you billable for the 66 seconds and validation matrices are here. You can see all the matrices. And obviously you can access the matrices as well from there on. View logs. Yeah. Meanwhile, the actual training is running on our data sample. We had it today to find something fraudulent or not. We can see the logs here as well. So you can find the logs, you can walk through it, and there's some quantity which is very important to determine. And data scientists in the call certainly will find a lot of valuation in here. You can also get insights, creating a visualization, the whole graph. So if in case you are observing the loss happening over the period of time as the model trained, it will be reducing down here. Yeah. So right now we do not have any visualization, but that's okay. You can visualize. It will be reducing the loss in the graphical, will show you many things. You can get the logs information here. Yeah. Okay. So with that, let me just find one of them. This is the one we shall ran in the past. No visualization here too. That's fine. So these are the all information you can get in the all training job. Let's see if our training job is finished. Now it's still in progress. It's going to typically it takes 3 minutes. So I have tried it before, so it would be the similar time. Yeah. We can execute on GPU also using this option. Yes. So if you remember, I will need to create another training job. So you had an option to add more chips. You can choose the GPUs. You can use any type of EC2 instance you want. So there was a question if in case you want to run on the GPU. So whichever type of EC2 instance you want, you can get it based on your training compute requirements. I think ours still running in. Okay, now it's completed. So yeah, you can see you will be paying only for, okay, so little slowness with my internet. Bandwidth is used for presenting this session. So 81 second only. I'm going to pay for 81 second. SageMaker time series is disabled now because we have everything available in the logs now. You can see algorithm metrics, instance metrics as well. The laws, which is very important part to understand. If it runs for like couple of hours, couple of days, all information can be observed in the visualized logs as well. And you do not pay anything beyond this level. So coming back to our Notebook now. So in this particular example, we have not used the hyperparameter. Just remember that. So now we are going to get the model is basically trained. In this case, we are going to use small data set. Training should not take 2-3 minutes. That's what pretty much it did. And then, by the way, we could run if the model successfully running the prediction here. Okay. So yeah, it is going to tell us if the training has been done or not. You can run it here. Response. You can read the response from here. So what has happened? You might remember the previous slides, which I would say just remember that slide only if this is more complex to you. So S3 training data is here, brought onto the brought the algorithms from container registries, and we train the data, and then further we will be deploying it. So next step now is for the deployment. So what it will do, it basically consider the 3 steps involved in having a trained deployment data. By the way, why don't we go to the S3 and see in there if there is any value? Yeah, training data was there, and next is modeling. So create a model definition which acts as a placeholder. Specific location for the model artifact would be S3. As you remember, we will have a new S3 folder for that, and creating an endpoint configuration from wherein the all communication will happen. Using the model definition above, that configures such as number and types of instances to be used. Yeah, once the endpoint will be deployed, there will be an instance for your inference. So this will be creating an endpoint using endpoint configuration above, which creates SageMaker managed container inference code. So let's go with that next. So it has created a model definition. Yeah, remember we need a so let me just show you back in the SageMaker. We should have a model package now. Yeah, so there it is. Model package is created. The second step is to create the endpoint configuration. So for that, we need another EC2 instance to run all the prediction onto that from that model. Yeah, so let's go ahead with that. So now it is endpoint is configured. Finally, in this step, what we are going to do, we are going to step of deployment for the model behind an endpoint using the endpoint configuration. So behind the scene, what is happening? SageMaker provision instances of desired type, which we have considered, pulls the model artifact, which we got it after training the model, and configures the runtime, which will take around 11-12 minutes. And then it will be beneath 30 seconds it will take to commit the beneath the cell. So you will be able to see that. Once the endpoint creation process is complete, the state will change into the in-service. So it's going to take time, guys. I will just run now. Yeah, and that's pretty much it. So it is going to create endpoint, and in the SageMaker, we can see now endpoint configuration is there, and endpoint is in the creation for your user to make a connection. So pretty much what we have done is created the all communication with the S3, and we prepared the model there using the training, and after that we have created the endpoints, which is going to take some time. Yeah, so next would be to test the model. We cannot do it before this gets over. So model testing would be done. To do so, we will validate the data against 200 sample records we have. If you remember, we have captured 800 different rows and 200 different to validate the data. And next one comes the Test records loaded. Shape, we will see that here. Testing. So each record of validation data will conduct the following steps: create a data dump without data column, transform into the input records following the format expected, and specifically it will use the comparison result appropriately classify as a true negative, true positive, true positive, false negative. So true negative as an example, which is truly determined was not fraudulent, right? And as same goes for the others. So one indicates the fraud, and zero would indicate the no fraud, which is truly determined and not truly determined. So that's what we will run the sample against while doing the validation of the data. Yeah. So next would be to validate it, and then we will invoke the inference endpoint. Then we will compare the target with the predicted one, and we'll find the result of it. So I'm just going ahead. I'm not going to run all of them right now because we're still in the progress of getting this endpoint creation. But yeah, since the results are here, what you will get it out. Uh, Let me just come to the comparison. So what we will get this after the results, once the execution is over, we're using the uh, linear learner here in the SageMaker. The results are giving around 0.054 as a precision, determining the uh, rightly find out the fraud, not fraudulent. Yeah. So that was for 0, right? If I'm not mistaken. Yeah. So that would be, we will get as an output. But what we have figured it out using this scikit-learn logistic regression, giving us the 0.63 as an output, and using the SageMaker linear learner is giving us 0.54. You might say, so it was a linear learner using SageMaker is not good enough. Yeah, we can say that, but one thing to remember that we have had not used the hypermeters even with the SageMaker, still doing a lot of good job finding it out 0.54 as an output. Yeah, so I think we can go ahead with it once it is done. By the way, this was the whole demo to showcase how everything goes around in SageMaker, which we have covered. And after this completion, I will have this endpoint created for us, which we can use it with our in our product. Yeah, so we can productize it. Okay, so guys, this was a very quick demo of it. Some of the part we did not go through since it's going to take some time to create that. And yeah, then we run the samples. That's pretty much the whole ML pipeline we conduct. Next part is, let's come now. We have the output. You can see this is the output we have obtained from the model. Yeah. So it has all configured here. Okay, so this was the demo around that. But if in case I'll see that if I can share with all of you this notebooks or not, if in case yes, you can try this out, and that also consists last part of it wherein you can go and remove all of the endpoint. I will highly suggest you to be mindful of your resources. So if in case you spin up something which is not covered into free tier, you might end up paying something for that. So yeah, very quickly, once you test out things, you can clear this using this delete endpoint config and model as well, all of them. Okay, so with that, let's move on to our slide. So what we have covered using SageMaker, we have SageMaker for heavy lifting after data discovery. So once we have discovered the data, format the data, clean the data, everything, we can use it for the training the data and deploying it. Configure the Amazon S3 bucket from the same console, ensuring the cleaning and preparation steps occur in Amazon SageMaker. You can use it in Jupyter Notebooks. Obtain container images from linear learner algorithm. So that's what we have done. So you can do it from the console, you can do it from the notebook if you have written everything in the Python. Create a training job, set hyperparameters. There is a section where you can define it. Or yeah, we had not used it by the way, but you can do it. Monitor training job status as well. Good. So there is a case study onto that. Last module we walked through the case SageMaker environment, and next module basically walks through additional hypermeter. We are not covering that, but there is a whole video which you can cover, which you can have a look onto. Yeah. So SageMaker inference debugging and monitoring, we somehow some of the part we have covered, wherein we created an endpoint and we deployed it. So what we are going to cover here is some of the deployment part, understand the SageMaker inference, including debugging and monitoring of the hosted endpoints. Yeah, so these are the two deployment options. After a model, model is trained, customer can deploy it to get the prediction in one of the two ways. First is using the hosting services. So customer can use SageMaker to set up a persistent endpoint to get one prediction at a one time. Persistent endpoint. Or on the other end, you can use SageMaker to batch transform, in a batch transform, to get prediction for the entire data set. Yeah, so for our any company fraud use case, we will use the first way. So you will use a persistent endpoint hosted through Amazon SageMaker hosting services. So that's what we are going to use it. Okay, so not to get confused here. So it's about the hosting services. What happens after model is trained? So once the model is trained, it is saved in an artifact, right? So once it is saved in the artifact, as we remember, we did it into the S3, it must then be deployed behind an endpoint. So artifact, from that it will deploy behind an endpoint. Yeah. So from there on, it enables to receive the request with data records asking for the inference. So in our case, this is accomplished by using the deploy method on the trained estimator. So we had run it. So deploying a model using a SageMaker hosting service is a three-step process, as we have seen that. Creating a model in Amazon SageMaker, then creating an endpoint configuration on HTTPS endpoint. Yeah, and from there on, next step comes is after the HTTPS endpoint, you get the your invoke endpoint APIs for you to use. So yeah, you pretty much it is showing about how it is being hosted once your model is prepared. Artifact, helper code, your inference images will come in there. I will just refer you to the previous slide I showed you. Yeah, so you can use the Docker images for the inferences as well. And then you give the inference response. Okay, so next is SageMaker Studio IDE. So simplify the things. We have integrated environment, which is as an IDE available for building or training or deploying the whole environment. So this can help you to use SageMaker Studio. It's, by the way, it's right now in preview, but you can try it out. So it's a visual integrated development environment that unifies the ML development tool. Say, yeah, all the development tools will be integrated in here. SageMaker Studio IDE can help developers to code. You can write down your code, create your own libraries. You can use it to build, train, deploy, and monitor the project from a single unified space as well. Yeah, so that's pretty much you can do. It's a very new service, but yeah, right now in the preview, you can try it out. So SageMaker Autopilot is the next one. But there is another one we have launched, Autopilot. I'm not sure if it's a new one. So developer using this can access automated data visualization and analysis surfaced by the Amazon SageMaker Studio. Yeah, so You can use it implementing a successful ML model. Usually is very complex, so that can help you with that. Uh, with all the implementation around it. So you can build your effective ML models. Experienced developers must inspect the raw data and apply the feature engineering, feature selection to clean up that and pre-process the data. That's pretty much can be done by the autopilot. Yeah. So you can offload those undifferentiated, sometimes heavy lifting tasks from you. SageMaker experimentation experiments. It will help you with these trainings and experimentation processes as it tracks and maintain the multiple combination of data, algorithm parameters. It will observe the impact of incremental changes on the model accuracy. So you can try different things. Yeah, visualize the experiment and compare the results. As in shown in this graphic, you can see the different models in there. You can. It's just like a leaderboard for you. Yeah, so you can see which model is performing well. Like in our case, we could figure it out. Uh, uh, Logistic was not doing well enough job. Yeah, so that was doing well enough job as compared to the other. We tried it like uh, uh, yeah, other models we tried with tree disease and everything. Yeah, so that's SageMaker experiment can help you, and then comes this debugging. So SageMaker debugger, you can see there's a lot of features, and all of them can be obtained as a one part of IDE. So debugging and profiling will help you with this. For instance, ML developers require a high level of ML expertise, right? They often lack the adequate visibility into these into what's going around back in the backend system. So you can use the debugger in that regards, which can help you to uh, find out what's going exactly with your model inference and everything. And and this should be the most important part as well once your model is in production, to find out if it is working well enough or not. So this is how the UI looks like. I'll just skip that part for you to have a view onto this. So you can see everything is being debugged, showing in the visuals as well. So there is a model monitor. You can monitor the model after ML model is deployed to production. Continuous monitoring is very critical, so developer can track the performance of the changes is happening. Model can drift due to data divergence, so you can just monitor it, find it out. It can help you with understanding what is going around in your system in a very graphical way. So you can see on this screen right now. So you can see how many endpoints are in status, how many endpoints are failed. You might need to launch new endpoints for that for that sake. So every monitoring can help you with that. So this new service, model monitoring, debugging and monitoring all together. So model deployment to Amazon SageMaker, auto scaling inference APIs are available for you. So A and B A/B testing you can do in a different samples. Low latency and high throughput. Bring your own models as a Docker image. You can bring it, and Python SDKs are available for you to try it out. That's how you can deploy your model onto the Amazon SageMaker from the right point, starting with the training, building to the point of deploying it. It's a one platform for you to do all of those tasks. So there is another case study for Alexa, which you can have a look onto. I will share this all information with you, and let's have a very small break for maybe 5 minutes. Then we can resume. Yeah. So I will have a look onto your questions as well, which we can might get an answer to. So let's have a break for the 5 minutes. We will resume in next five. Okay, guys, so we are back now, excited about something, and that's what is our last part of today's session. So, most of the data I'm hoping to share with you, but if in case not, I'll try to give as much as information I can with my email. So for that matter, just uh, have a little patience. So I might send it within 1 or 2 days. So maybe day after tomorrow. So today is Monday, Tuesday, Wednesday. So after marking you all of you in this session, then I will send you the data. Usually I try to do it the same day, but just there were some questions which might need to take offline and help you with the answers. I will consist all of the information uh, in my response to you in the email I will send you afterwards. And for the email, I will have all of your email addresses. So since you registered yourself with some of the email, I will take that one and send you the data across. So don't worry. And there is a question for tomorrow AWS security session. Can you please forward the link? I am not running it. I don't know who's running it. Uh, tomorrow is on security. Tomorrow, no, there is. Okay, someone might be running it. It's not me, Rahul. Sorry. But I will try to find it. So write me an email. So let's take those questions by the end of the session. So let's cover something we are left with, and then we'll take all of your questions. Don't worry. Yeah. I have no setting to change the volume actually. Okay. And now we are going to talk about Amazon SageMaker at the edge. So what exactly that means is going to talk about briefly about our service called as IoT Greengrass, which is machine learning inference. So you run the machine learning at the edge. Yeah. So understanding IoT Greengrass, understanding common use cases, and identify Amazon SageMaker. Neo. So IoT Greengrass is one of our service which extends the AWS IoT functionality to the customers. Yeah, that's what the definition is. So what exactly is it? To understand the IoT Greengrass ML inference, we must first learn about its parent service IoT Greengrass. What exactly is that? So IoT Greengrass extend the AWS onto the customer's device, so the device can act locally onto the data they are generated while sitting onto the customer side and still taking the benefit of the cloud. Yeah, so that's where your IoT Greengrass is running in, and but still having a connection with the cloud at the backend. So with IoT Greengrass, your customer don't have to send their data to a distant cloud. Data is stored locally. Yeah, device storages. There you can have your data stored locally, which will save time, especially in the case where you need millisecond latency. Yeah. So you also customer can have a choice of sending the data back to the cloud as well for improving the models, improving your uh, machine learning more deployments or models and everything. So which is typically we called as inferences. So Greengrass, IoT Greengrass will enable devices continues to route the local messages when data must stay local for the data sovereignty. We know that for all the law of the land, it will keep the data onto that place, and this will help to ensure the data is secure and kept local. So IoT Greengrass does this using this same security mechanism and encryption. It is used in the cloud with the AWS IoT. So it's updatable, so customer can access new features, security enhancement in the future as well. So it does use the IoT services of AWS. Yeah. So what are the benefits of using it? It's a very flexible to use it because IoT Greengrass includes the pre-built TensorFlow, Apache MXNet, uh, and chainer packages for devices powered by the Intel Atom or Raspberry Pi as well. So these devices can be uh, using the any choice of your platforms like MXNet or TensorFlow or whatever. Yeah, so your customer don't have to build and configure the machine learning framework. So you prepare your model and you just use it, download it. And in addition, it works with the other popular framework as well, for including Cafe 2 and Microsoft Cognitive Toolkits as well. If customer is using Amazon SageMaker with AWS IoT Greengrass, model written into these frameworks are converted into portable code which will run on any device. So very, very flexible as well. So just a few click away to deploy models to connected devices with a fewer clicks. Using AWS IoT Greengrass makes it very easy that you deploy your ML models from cloud to the directly to the devices. Yeah, so using the IoT Greengrass console, I cannot show you because it requires all of a lot of configuration. But yeah, you can just find out how to do this configuration and build the solutions. Yeah, so it also can, what it can do, it can also have the, as you know, where SageMaker is integrated with the S3, so you can use the selected desired model from there. And so Accelerate talks about the inference performance. So it has integration with the Amazon SageMaker and deep learning compilers. So customer can deploy machine learning models with an optimized runtime that run up to the twice as fast compared to the hand tuning or using ML frameworks. More devices. So there's a lot of devices can be used having the integration with Amazon SageMaker, and model is optimized with to run with all of the different types of devices and easily run on inferences on a connected devices and accurate models you can predict. So many benefit. I'll just highly encourage you to have a look onto uh, IoT Greengrass model. So how it exactly it works. So with Amazon, with AWS IoT Greengrass ML, yeah. So inference, by the way, so what it does, the core device performs the inference locally. Yeah, and you can take the action very quickly. Having it once completed, it sends the data back to the cloud. So you can take the action accordingly. So you can improve the model accuracy. So data is sent to machine learning services such as Amazon SageMaker, machine learning services of your choice to improve the model accuracy. So if in case new data is there, you can bring it back and you can train it, optimize it, and then send it back for the improved model. Where do we use it? Video processing, retail and hospitality, and security, precision agriculture. Yeah, so these are the typical use cases of using the uh, IoT Greengrass. So another type, we have to run the Amazon EC2 Inferentia. Inferentia chips instances are available. By the way, this is one of the new launch we have. That's why it's been here. So EC2 instances are, by the way, built up from the ground up to support machine learning inferences to reduce the cost and machine learning inferences in the cloud. So I think it was 40% cheaper as far as I remember as compared to the other Inferentia, another chips we do have. Yeah, so it is featured AWS Inferentia, first custom ML chip designed by AWS. So couple of years back, we have acquired one company called as Annapurna. So very dedicatedly, they are doing what is basically creating the chips. So we have prepared this one for the ML purpose. So it helps to increase the throughput and lower the cost per inference. So as you know, it's a very cost optimized resource to use. Yeah. So yes, it is 40% lower cost per inference. So integrates with the TensorFlow, MXNet, PyTorch, and Neuron SDK. Can be used for multiple purposes: for speech recognition, for image processing, fraud detection, object detection, and many other purposes. More information would be available here to find it out about the inferential chips. Augment, augmented AI, you remember we talked about labeling the data using ground truth. So ATO is similar to that. Once there are some of machine learning applications require humans to label with the low confidence predictions at the edge of inferences. So for that, you can create the workflow using the augment AI. So it helps basically the developers to build the workflow to review the whole ML prediction. So it brings human review to all developers, removing the undifferentiated heavy lifting associated with building human review system. So managing a large number of human reviews. So it can do it on your behalf at some of the workflow additionally. So how does it work? You input the data, AWS AI service or customer model makes a prediction. Augment AI gets into it. If the confidence is enough, like more than not 1%, as a value is 1, you put it as a high confidence, you can put into the client application. If in case not low, you can send it to the for a reviewer, for the human review. So once your review is consolidated using weighted review scores, like I talked about 1 or 2 or whatever you have put in there. So once it is done, it is stored into the S3, can be reviewed later, and yeah, and you can send it further on. It's a fairly new service we have launched. So this section is going to talk about the topmost layer. So guys, what we have covered in the morning, we talked about our 3-layer stack, putting machine learning in hands of everyday developer. First, if you are an expert, to manage all of things I have shown, like creating your own training environment, stitching the storage together, saving the models, artifacts, then using some on Docker images to deploy it at the endpoint. Or you can use the second layer, which is a platform as a service, SageMaker, doing everything for you. Yeah, you bring your data, cleaning it, visualizing it using notebooks, you get a notebook environment, and that's it. Yeah, then you get an endpoint after trained model, you are good to put into production, and it scales automatically as well. The next and the topmost is the AI services we do have, which I called it out. You can just take it off and start using it. Like one of your application needs image processing, why to write millions of codes? You can use the AI services which AWS has produced. We have a most available AI services as compared to any of the provider has. So let's see what are those AI services available. So that's the topmost stack in there. Vision, from the vision point of view, Amazon recognition images, Amazon recognition videos. So images like we'll do a short demo. It will automatically identify if you put a celebrity picture, it will find out it's Jeff Bezos, it's Salman Khan, it's a whosoever. So it will do it on your behalf using what? ANN, so artificial neural network. So using the data samples available, using the information, it will help you to get the answers. Yeah, so one by one, let's see in a different segment from vision, speech, language, and chatbots. First, recognition. So let me showcase you the demo onto that. So machine learning, SageMaker we have done. There comes the recognition. Okay, so it's a little delay in your view, so I'm going slow. So it's so yeah, herein. So we have a picture here. It tells us there are vehicles, 98% with the confidence. Automobile, that's where, yeah, automobile is there. Transportation, so it tags the picture as well. So what it does, it use the deep learning based image recognition and analysis services. So it takes an image as an input and it does the labels. For example, you can see in here human, person, and there are many more. Sports, building. So whenever you put a picture here, sorry, I was not ready for the demo, else I would have kept my own picture saying it looks like celebrity. Yeah, okay, there is some of them. So sorry, jokes apart. So like I just uploaded one picture. Let's see. Yeah, I randomly did it. So it talks about water is there, 99.8%. Dock is there, building is there. There is in the background a lot of building. I was expecting a bridge. So there is a bridge within 97 and 60% it's a confirmed it's an outdoor. So it talks about all the taggings and help you with the deeply learning it. Yeah. By the way, there is another one is how, how do you use it? And there is a moderation as well. There are some other features, not just one. So if there is something you don't want to showcase, it will also predict that it's a sensitive pictures. Yeah, you can have the moderation to that. So it's a family picture. That's why it is saying it. Yeah. So you can use that APIs and can uh, yeah, and you can integrate with your solutions. So you can see facial analysis. So it's looks like a face, which is 99%, smiling, wearing glasses, open eyes, eyes are open, 99%. Okay, it can see through the glasses as well. Mouth is open. Okay, so yeah, a lot of tags as well. So celebrity recognition. So a lot of uh, features you can find in here as well. Yeah, face comparison as well, which is being used by one of the NGOs to finding out the child to find the childs which are by the way abducted. So for the child sex trafficking. So one of the NGO is using it big time. So that's one of my favorite customer to compare with the victims with getting the all the images coming from the cameras around the city. They were able to find a lot of they were able to save a lot of kids in there. So it can also help you to find text in image, and this particularly uh, is relevant today. So it's a Monday, but keep smiling, guys. So video analysis as well. This will be a little tough for you might be to see in the real time because it's a online session going on. But once the video goes on, it will help you to identify people in it, celebrities in it, and other tags will be there. Yeah. So one of the place we used it was one of the customer named as Sky News. You know, it's a British media news house. They used it for the Michael Meghan's marriage with Harry, Prince Harry. So everyone who was entering the premises of their wedding, they were showing in the real time. Yeah, they're all wedding. So the real time they were showing in uh, which celebrity is it. So tags were seen there. So it's a David Beckham. It's a David Beckham's wife. Not with this name, it will be Victoria Beckham. She is a celebrity in herself. So yeah, so that's where you can use it. That's pretty much deep learning it is doing. And next one is language services. Amazon Lex is a chatbot. So obviously we cannot do a demo for it, but I can talk about it. So it's a conversational interface for applications. So it's powered again by the same deep learning technology as an Alexa. When we say Alexa, how are you? Alexa, read it as a text. Yeah. So based on that, it will trigger an intent. So Parvesh has asked about how she's doing today. So based on that, the answer will come back. Yeah. So customer can use Amazon Lex to build the conversational interfaces. And it's also integrated with the Lambda functions and many others. So you can have a try on that. to create your own chatbots. Amazon Polly. So Polly uses the deep learning to turn text into lifelike speech. Polly. So for example, customer enters the text and then select a language, a region, or a character. Like in India, it's Aditi is there, so Aditi will speak out for us. Yeah, so it can have different languages. I think it's around more than 20 languages. It now also includes uh, Hindi as well as Tamil as well, I think. Yeah, so there's a lot of languages are available, so it can speak it out. Anything you can write in down there. Let me just try it. Poly. So before we were running these trainings uh, in instructor-led classes, wherein we used to do a lot of fun with this. Yeah. So yeah, you can see a lot of languages in there. Hindi. Let me wait before it turn up for you. Hindi is there, and then there is. Oh, I was expecting there were more than one Hindi language, but that's okay. Yeah, so there's a Ravina has just come up, and there is a Aditi in the female different voices which you can use. Yeah, so once I will play it, it will read it out, speak it out, not read it out. Okay, so Polly is for that. So what else you can do with this? Once it is done, you can download the MP3 or you can put it onto the S3. Language service, Amazon Transcribe. So it's an automated speech recognition service. So customer can use it service for the speech to text transcribing. Yeah, so you can use transcribe to create a transcription job. So many of the news center now using it to get the send the big data to the customers as well. For example, something happened on the 9/11, so all the news at that time you want the all information. So what you can do, you can play the videos or whatever audios you available with you, MP3, MP4, and that will transcript all the information. Yeah, it will write it down. From what you can do with that, you can use next to that is maybe comprehend. Yeah, so or maybe translate English to different language to showcase it to someone else. So that's pretty much you can do with it. Translate is the next one is uh, neural machine translation service that delivers fast, high quality language transition. So from English to Chinese to French to any other. So you can integrate it. It's all APIs are available for you to integrate with your solutions. So are you dealing with the documents? Yeah. And that is very demanding. It requires a lot of time and lot of either you write your own OCR code for that, or you use it something which is available for you. So so we use traditionally OCR, which will help you just with the written letters, not will observe the tables or something in the highlights in a different format. So that's been very cumbersome beforehand. So in traditional way, all extract in the document onto the left without considering how the characters are placed will be shown here. Yeah, you can see it's a very randomized output we are getting. Then you have to do a lot of efforts to fix that issues. For that, we have Amazon Textract, which is OCR++, which takes a different approach to OCR by recognizing how document text is formatted. So as you can see here, the table and the chart is separated from the paragraph text altogether. Yeah, so the text is there in the next slide. You can see now. Yeah, so tables can be extracted and retain their form as is. Data can be sent to Amazon Aurora database for use in application using the APIs. So it has a integration as well. So for example, here there is a whole form in this. Amazon TextWrite can extract it and send this whole form information uh, to the database, which is Aurora. In this context, we have taken. Yeah. So TextWrite can also analyze forms, and each field metadata can be retained with its associated data as well. X forms, US example you can see on the right side. So it's a very high uh, information onto that. So there are some questions flowing on, guys. In interest of time, what I'm going to do, I'm going to take them off while writing back to the email. So one of them is, does TextRect have integration with DynamoDB? I am not sure about it. So AWS as well can download model these images recognition. It will wish to use the local testing purpose. You can use with the APIs we have shown. You can integrate using the APIs. So yeah, as you have a question in that. So, and as you said, pre-trained model, I'll take those questions further on. So TextWrite can extract text and data from virtually any document, extract data quickly and accurately, eliminating the manual efforts and lower the prices. So it's a key features. OCR is there, plus plus by the way. Key value pair detection is done, table detection, adjustable confidence threshold is given. Yeah, bounding box coordinates as well. So language service, it's a very nice one, is the comprehend. As its name suggests, it will comprehend the sentiments. Yeah, so let's see this one. Okay, so comprehend is there. Launch Amazon Comprehend. By the way, there is a new Comprehend also launched for the medical, specifically for the medical as well. So for all the doctors who are suggesting you, yeah, so you can use it. It's newly will launch. So this is one of the statement. Once it's a built-in one we are using. You can put, by the way, your own analysis type. Yeah. So once we run the analysis onto that, it talks about category Amazon.com. It's an organization. Jeff Bezos is a person. Portland, it's a location. Seattle, Vancouver, South. So you can see there is a lot of category it's come up with. Confidence it is also showing. I don't know, somewhere it mentioned the Starbucks as well. Based companies like Starbucks, yeah, it says it's an organization as well. Boeing is an organization as well. Talks about the confidence as well. So yeah, a lot of information you can extract, sentiments, key phrases, language used, English, 99% confirmed, sentiments, confidence. So in the morning, I shared one of the example. Deloitte has prepared the contact center. Yeah, Deloitte has prepared the contact center. They are using Comprehend to understand the sentiments of the users. Yeah, so custom real time analysis with the endpoints you can configure as well. Real time analysis for the medical as well. So someone is talking about, yeah, there is some examples. It has a status post, cardiac issues, April 2009, and that's all been found out all the information onto the health. So so basically it can detect up to 100 languages as far as I remember. So yeah, languages are like English, Spanish, German, French. It can work with them. Okay, so you can also put the whole file here and run the batch processes. That's pretty much uh, comprehend does it. So next, how can you help your customer? You might already be having idea, which I can see reflect into the chat as well. So there are a lot of questions I might like to take right now. So Can we get coordinates each properties for TextRect? There were coordinates for the I don't know what exactly was that. So I would highly encourage for all of you. These all services are at some extent is free tier available. So you might have a lot of questions how to exactly integrate with your service. There can be multiple use cases. So as it's a API driven, you will get the APIs for you to integrate it with your services. Yeah, just try it out. And I will take very specific questions. So just extract. I'm going to help you with if in case it's integrated with a demo DB or not, as shown or it is. So for AWS Greengrass, as you said, pre-trained model can be used onto the device, but the data on the device is present in the raw volume, raw form. How does pre-processing or data takes place using this concept? Now I will answer that too. So can I feed external ontology to AWS comprehend? So yeah, I think I answered that. You can add external. At the very end, we talked about if in case you want to add something, you can have your own analysis jobs running. Yeah, you can create your own job and you can put the data onto the S3. From there on, you can use it. Okay, so how can you help your customers define what AI services can help them to solve specific business problems? So here are the some of tips you can use. You can add value to your customers for the machine learning projects. So communicate to your customers. Describe how AI services are designed to address specific business problem. For instance, Amazon recognition with the help of images and videos recognition, Amazon Poly, converting the text to speech, and all those we have talked about. Yeah. So further on, explore for all of you. This would be the next call to action. Explore AI services in the AWS Management Console. So many of them are uh, very easy to use it. So you can try it out uh, for the free tier and figure it out how it is going to help you. So yeah, so and then further on you can complete the tutorials which are available. There's a lot of by the way tutorials available on aws.training for each of the services we had talked about, like of contact center. There is a for SageMaker, many of them you can go for that. So with that, let's have a last question asked. So your customer is an IT director for a state justice department. They want to record court proceedings to MP3 files, then convert the recorded speech to text. Which service you think required to solve this challenge? MP3 speech to text. Guys, don't get things wrong. Poly is what? Poly is text to speech. No, whatever I say, Poly will call it out. So what do we need here? We need here someone is speaking and we need to create text out of it. So whatever I am talking right now shall be written into transcript. Onto the YouTube videos we listen, the match commentary, sometimes live it is written. All hands within our companies are transcripted. So you need a Amazon transcript. So I now say that you should try the machine learning AIs. Oh, sorry. In the vertical of machine learning in our console, the services are there like Amazon Poly, Comprehend. It's a very easy to try things out. You will understand how you can integrate them with your solutions as well. So transcribe is the right answer. So many of you got it right. Once again, Poly is going to speak out loud for you, like speaking out. Alexa speaking for you. Amazon Comprehend is comprehending or comprehensively understanding what exactly context of this. So it will tell me, for example, it's a IT director. It will say the role director. So what it is used for example, it will say organization, justice department, some sort of this. So yeah, that will tag it, that will tell you key features, tell you the sentiments. Yeah. And transcribed is about transcripting, because someone is speaking the proceedings. That will, and Lex is chatbot. Yeah, to create a chatbot. So now returning to the any company use case, guys, you remember we had resolved the fraudulent case using some of the machine learning model. Yeah. So can which AI service do you think we can use now to get the issue resolved of the fraudulent? Can we use any of them? Can we use any of the AI service? Comprehend. Uh, which way? Not actually. The answer is that we cannot. As of October 2019, there was no AI service we might use with it. By the way, but I think there is a new service we launched and we talked about it, right? So uh, there is a, what's the name of that AI service to determine the fraudulent cases. So that can be used, but that is for the credit cards, and yeah, need to be observed what are the use cases we can use in there. By the way, no AI service we can use as of now we think of directly with the use case we had at hand. We had to prepare the machine learning model using our own whole data set. Yeah, but that's okay. So next one, so there is an answer. Understand the text in transaction to detect pattern anomalies using comprehend. Okay, we can try it out. So next step is to identify and describe the AWS machine learning competency program. Don't worry, we're going to talk about, and these are the topics. Let me just move on. So mm, here, so now you need to start your path. So there in our today's class can be many people who are first time joining any ML session, and today's class was very introductory type of. It's not diving deep. I am sure many of join in to get the most complex answers given, but this is one of the introductory call meeting we have, wherein we showcase the uh, how technically you can use the whole framework. Either you are a data scientist, either you are a developer, either you are a business decision maker, or you are a data platform engineer, DevOps, whatever. How you can use the platform. This can be your beginning point where you start with seeing the capability of the platform, right? So then you start further with the machine learning path. You can define either you are a developer, you are a business decision maker. For that, we have a machine learning path. You can find your machine learning path onto the on our website. By the way, the easiest way to get to find the machine learning path and finding the trainings available as well onto the our uh, our digital platform. You can just write down learning path for machine learning. I should have written AWS because it will not be very specific. Can it give for data scientist? There it is. So yes, guys, so you can find your learning path from herein. You can see there are classes available, machine learning pipeline, which is virtual or 4-hour session for you. This is an amazing session, by the way. Check it out if this is available for you to try it out. Yeah. And yeah, so there are a lot of others. So learning path is down here for machine learning. This will give you the guided path. So either you are a business decision maker, data platform engineer, you can explore that path. Yeah, so this is what you can follow through. At some point, you need to understand big data services onto the AWS as well, because we are bringing everything at one place. So as someone asked about the link, I have shared with every one of you. Yeah, it is now available, so you can have a look onto that. But very easy peasy, you can just go to the google.com and write down learning path for AWS machine learning. Okay, so next, many of you also started in the morning mentioning you are looking forward for machine learning specialty exam. Good luck. You can schedule it now, can get it done from home as well. Proctored session can be done. So this will help you to validate your ability to build, train, tune, and deploy the model, the whole pipeline. So yeah, so this today's session is not enough. It's just introductory. But if you are going for the exam, you need to learn from different platforms. So the training I have given can be also at some point not enough for appearing for the exam. Just find out what exactly. There are two ways. Either you can go to our authorized partner for the trainings, or you can get it done from the AWS as well. So we also conduct the trainings. Yeah. So as a partner, you can get in touch with your partner manager or your alliance leads if your whole team or your whole pack of people are looking forward to get certified onto this specialty machine learning specialty exam. So very specifically, we have exam for machine learning. So community is there for you to learn more things. ML community, videos, blogs, books, tutorials. So this link will be shared with you. And then machine learning competency. So this competency basically helps to determine as a partner, to recognize you as a partner, to demonstrate your technical proficiency and proven customer success in machine learning domain. Okay, so uh, for example, Deloitte, Accenture, PowerUp as well. These are the partner names. BluePy, the many partners. Let me just show the list with you. A lot of partners are uh, already achieved the competency. They have proven themselves as a machine learning expert in the market. Yeah, so you can achieve this competency as well. So you can find in here Accenture, Deloitte, Crayon. So these are all machine learning consulting partners. Cloudwake, Peak, Zebia. So many of the partners. So these are partners are uh, from the India location and having the competency of machine learning. They are expert in the machine learning. You might be associated with one of the partner as well, but yeah, your company or your organization can work in direction of getting this getting that themselves competent as well. So there's a lot of benefits of competency which we usually cover in our business sessions, but you can go through this link and find out how it is helping you with the sales enablement. If any technical requirement from the AWS side you need, our team will be available for you, as you are the uh, among the top partners who manages the AWS machine learning customers. So yeah, that way. So to help you get the direction to achieve the competency, we have a navigate programs. So these programs help to build, market and sell your specialized area. So that will guide you thoroughly. So this is very specifically for the new partners, or it can be for the any partner, but very specifically for the important for the new partners, I must say, to build their practices onto the machine learning. It's a guided path for you. And then API navigate for machine learning. Uh, there's a guided path for that, and that's it. So that's what can be done. Thank you very much for joining in today. And there were a lot of questions I could find, like one of them, AWS IoT giving us. Yes, Neha, I'll just go through a few of them. But additionally, before I answer them, let me know if you have additional questions, so I will get through before we put the curtains on our today's session. So guys, let the question come in the question board so I can take them. So yeah, Neha, you said the data is presented in the raw form. So exactly, you can send the deployed model onto the IoT green grass. So you can have the models prepared there, but if in case the raw data comes in, you can take that data back to the cloud, use that data, and process the into once again to create a new model and deploy it again. So that's the answer of it. But very specifically, if you that's the answer, that you have deployed the already pre-trained model, yeah, and data on the device is present in raw form. That raw form can be taken further and run the can create the model once again. But I will share with you one example for that. And what else can I? Okay, so Urbindo, you had got your answer already answered by yourself, which is good. Yeah, transcribe. Sorry, that can use medical transcribe for you. So edge processing itself means the processing on the device. Yeah, but if in case you need to redeploy it or train it again, you can train it. Yeah, nee, I'll answer that for you in a more details. Yeah, I will do share the content with all of you. So that's if in case you need to process the data once again. Yeah. And are there any further trainings you will be conducting as a part of this training? So, by the way, not related to this one, because this is a very specific as an introductory session onto the machine learning for the practitioners. Uh, but there are some trainings are uh, solution architect also conducting, which you can participate in. I'm not sure when is the next one is, and but you can find it down here. Let me share this link with you. These all are the trainings are coming in the next week and weeks. So what is today? Today is 5th. So this is what we are running today. We're conducting today's 4th, by the way. So tomorrow is onto the VMware cloud. You can join this one, and on the machine learning is the yeah, there is another one, guys. So it's a deep dive onto the AIML. So it's a technical workshop. I will highly encourage all of you to join that, since there were a lot of deep dive technical questions. You can have a go onto that. So I am sharing this link with all of you. One second. Where is my chat box? There it is. So just confirm me if you have received the link. So just join the next session, which is onto the deep dive into that. So assessment part, yes, there is an assessment which you can go for. So you find the solution training for partners, introduction to machine learning on AWS. That will be in progress. So select the resume button and locate the assessment and click on the launch. So you can do that. Yeah. So that's where you can launch it. So there is a question. As I have cleared ML specialty exam, congratulations, amazing stuff, Abhishek. Do I need to focus upon what about big data exam? By the way, big data, as far as I remember, is now been decommissioned, and would not say decommissioned, is basically been uh, changed with new one called as analytics one. You can surely go for that, Abhishek. Yeah. Analytics one. There is a new one, specialty exam on the analytics, and go for it. Or maybe you can also get a specialty on the Alexa builder as well. Okay, guys. So there are other questions. Please do let me know. So is this helpful for AWS machine learning certification? Uh, I'm not certain about it. But as far as I have feedback coming in, that's very much onto the big data side, and I don't know if that's required for the ML or not. So yeah, there is any interlink between them or not, I don't know. Abhishek, if you want to send me an answer on to that. So let's take the example of this. Someone has just messaged that he has cleared the ML specialty exam. So should he be looking for the big data? So it means they have done it without it. So I don't know if it is going to helpful or not. But yeah, if I am going to understand first the data relevance, I might go for the analytics one. That's the personal choice as well. But yeah, if it is a prerequisite or helpful, I'm not sure about it. But certainly can add if some value of it. Why I'm not telling you that you should go for that first, because that can consume some of your time. If you're going for the machine learning, I think you can directly go for that based on your experience. If you have worked a very lot for a lot of years already in the space of machine learning, you can directly go for that without having getting through the analytics or big data exam is there. Okay, guys, if there are any question, please do let me know. And everyone, for those I was not able to answer your questions and I need to get your answers in a very right manner, I will send you across. And once you will have my email with you, feel free to write back to me. Yeah. So in interest of time, I have not answered one by one in the chat right now. So email is this is my email address. So choprapa@amazon.com. So by the way, I will be sending you the whole content, all the information. So it will be sent to you across, so you can reply to that as well. Yeah. So have a good day ahead. Thank you very much for joining in. I really enjoyed the session. This was the first time we ran this session virtually. Uh, as for yeah, okay, now we ran it like last to last month. So second time we ran it. I thought it was before the lockdown. So yeah. Okay. So thank you everyone. Stay safe, stay healthy, take care, and I would check if I can send you the Jupyter notebooks, the Python, by the way, that Python scripts for your reference or not. And based on that, I will attach them in my email address, in my email sent to you. I hope you learned something out of this session today. So, yeah, with that, I will say thank you very much. Looking forward to see you again. Bye bye.